This conference will now be recorded.
Yes, am I audible?
Yes, sir. It's audible. It's audible.
Yeah. So, good morning to one and all. This is the fifth day, the last day of our online faculty development program, sponsored by the ISE Project 2 on the Internet of Things with the machine learning and artificial intelligence, organized by the GTU, British School of Engineering and Technology, Ahmedabad, and the Center of Continuing Education, NIT Warangal. As a coordinator of the FDP, uh, uh, and on behalf of the GTU GSET, I welcome our today's resource speaker, Professor P. Suresh Babu from the NIT Warangal. Today's topic is the role of machine learning in the Internet of Things. And I am very feeling proud to introduce Professor P. Suresh Babu. Professor P. Suresh Babu is the assistant professor in the Department of Computer Science and Engineering at the National Institute of Technology, NIT Warangal. He completed his doctorate degree from Jawaharlal Nehru Technological University, Ahmedabad in 2017. This area of the research are IOT, network security, wireless network, mobile ad hoc networks. He published more than 35 papers in peer-reviewed international journals and the conferences. Professor Suresh Babu received the CSI Academic Award for Best Paper Presented Award in 2018, Best Teacher Award for 2 consecutive academic years, 2015-16 and 2016 and 17 from the KEN University. So, I just welcome and hand over the session to the Professor P. Suresh Babu to take the session on the role of machine learning in Internet of Things. Over to Professor P. Suresh Babu.
Thank you, Professor Gautam, sir. I thank the coordinators for inviting me to share my knowledge to the learned professors. I once again thank for giving the opportunity today on the last session. Very good morning to all of you. Right. Thank you, sir, for your brief introduction regarding me. I'm very thankful to you. We start the session. Just I want to ask, because we came the end of this FDP program. I think you have come across the various the technology that comes under the IoT along with the machine learning technologies. If you search something like in the Google, or if you search something like ML with machine learning, I think very few papers you're going to see, very few quality papers you're going to see, because it's a very new area, right? Though machine learning is not a new concept. People who have started using AI and machine learning from last 20 years, but the industry took up this machine learning and AI, and the people who have started enjoying the fruits of the ML algorithms, how can be used. Because when you see last 3 to 4 years, people were talking about the value for the data. There is a lot of value for the data, it is there. Now IoT is going to give a lot of data to you. Now we need to apply those data for efficient decision making. That's an interesting point. Now I want to know certain questions. What is this IoT is all about? I am audible?
Yes, sir. Yes, sir.
Yeah. Just a little bit interaction to the participants, so that I'll go my sessions. Like, if you're already comfortable with ML, if you're already comfortable with IoT, then we need to combine. We need to apply the machine learning algorithms in IoT, because IoT is a big ecosystem. It's not one technology, it's a multiple technology, or something we can call them as it's a technology integrator. Right? If you are learning IoT, which in turn you need to learn big data, you need to learn 5G, you need to learn cloud computing, you need to learn wireless sensor network, you need to learn fog computing, right? You need to learn machine learning. So definitely, if you want to build an IoT ecosystem, definitely the other technologies also will play a very, very, very important and vital role. Okay, so I want to know what you have learned in IoT. Just I want to ask a few questions. What is this IoT is all about, and where we can use this IoT? No. My screen is visible.
Yes, sir.
Yeah, right. Now, the role of IoT in Internet of Things is my given topic. Just I want to give my session will go like something like we are going to see the importance of the IoT, then IoT architecture, then where we can use the IoT ML in IoT. Right now, just let us see from last 40 years, we are enjoying the fruits of information technology. We have started using these concepts of the waves of information technology, like starting from mainframe, which is started from 1960s to 70s, and then mainframes were replaced with mini computers from 70s to 90s. Then we have a microprocessor, rich set of VLSI integrated circuits concepts will come into the picture. Because of that, people were started using microprocessors, and they're using the legend companies like Microsoft, Intel, Apple, IBM, Sun System, HP, back. There are so many things out there. Then the era which we are enjoying, which we are going to use from last 5 to 10 years, we are here in the network and distributed computing era now. Now, the future, as you already know that, when you see in future area, in computer science, actually in computer, there is a major problem in computer science, because unfortunately, where we can see what is the problem with in computer science, in the sense you need to be updated, otherwise you will be outdated. Always you need to be get updated. Every 5 to 10 years, new technologies will come. We need to be get updated, otherwise we'll be an outdated. Now, this era, whatever we are calling them as a distributed era or industry 4.0 era, which we can call them as, it is not only one area is going to change, but all the areas need to be changed. If you take a civil people need to be adapted, mechanical people need to be adapted, electronics people need to be adapted, EEE people need to be adapted. The education system need to be changed now because of the industry, because of the technology which are coming very close to the people. So the future is all about the IoT, and we are enjoying though the cloud, which we are enjoying the fruits, but we are going for distributed cloud. We are not whether the cloud is centralized or distributed. Whether the cloud is centralized or distributed. Yeah. Oh, it's distributed. Okay. I don't think it is a distributed, though virtual machines inside of that it is distributed, but it is still a centralized system, right? We are using a centralized. My voice is not audible.
Sure, sir.
Audible, sir.
No voice is here. Is someone is? Yeah. Right now we are going for a very interesting one, right? IoT plus cloud plus big data, which we're going to see. Then which we are going to call them as what is the industry 4.0. We are talking about the industry 4.0. Now, when we talk about Industry 4.0, there are so many technologies will be there where the Industry 4.0 is all about intelligence system, which we are going to call them as the intelligence systems will play an important role in the IoT. Right. So we are saying the next innovation which we are going to talk about in the sense here, the IoT plus big data, which we're going to lead to because why we call them as an IoT in the sense IoT is usually there is a difference is there between traditional IT and IoT. Now, traditional IT, we usually deal with the databases, the servers or applications which we're going to use it, right? Even we are using a cloud as a traditional IT. Now, when IoT was introduced, then it is going to generate the data. Now, IoT is going to generate the big data. Now, we need to apply some learning algorithms, some AI principles there. Some AI principles we are using to make that big data into smart data. Right now, how to convert that big data into smart data at which level we need to perform? That's a challenging issue. That's the next innovation, right? So why in the sense because we are going to have a data explosion here, where you can see 34 zettabytes of data is created in 2020. And what is the challenging issue is already there are more devices than people. People are behind the devices. The next one. Then already by 2020, 50 billion devices were there. We are connecting. That's a very very challenging which we are going to have. So just I want to quickly. Anyone has covered Internet of Things concept? Anyone has covered Internet of Things concept?
Yes, sir. Little bit, sir.
Yeah.
You can go ahead and ask for the Euro.
Yeah, okay. Because if any redundancy is there, please let me know, sir. Gautam, sir, you just inform me so that if any redundancy is there, I'll remove it. Okay. Now, see, people are talking about if you see from last two to 3 years, actually, whatever we are talking about, someone will take Raspberry Pi kit, someone will take Arduino kit, someone will take Z1 Node kit, and someone will take some other devices, hardware devices. We are having different, which are designed by different manufacturers. Now, the IoT is not all about a single device, or the IoT is not all about connecting one or two devices. Now, when we talk about Internet of Things, some millions of devices will come into the picture because the device-to-device communication or machine-to-machine communication is going to happen. Now, if such is the case, definitely we need to learn some important concepts of this IoT. I'm going to give overview of this IoT concepts which you're going to see. That what is the internet? The internet plus things plus data. Now, when you see the internet, because we are enjoying the fruits of technically this internet is nothing but a protocol suite. It have a rich set of protocols, and we are enjoying very efficiently the internet. The next one is the things. When we say things, because we are good now. Previously, there is a concept called IOP. Who are using internet in the sense? People were using this internet. Now, this P is replaced with the T. We call them as the things. Now, things are used to connect to the internet. And these things is going to generate the data. So, therefore, the IoT is IoT key components or key keywords is the internet plus the things plus data. Now, we'll try to see, though these three words are very simple, but the ecosystem is a very complex one. The IoT is a very complex system, right? Now, we need to handle this complex system. Right, IoT connects all the things, so therefore we call them as the Internet of Things. If you see here, whatever we have, if you see, we have one sensor. Now, these we have another sensor, so we have another devices. This is another device. This is another device. This is another device where it is connected to the internet, to some communication medium. So therefore, IoT connects all the things. So therefore, we call them as the Internet of Things, right? Which is or someone will call them as a network of things. Someone will call them as, if we are using on web of things, which we're going to have. but they're different concept. Though we are using different terminology, but the concept is same, right? The second one is where the second keyword is things, which is we call them as a high constant nodes. Why we call them as a why we call them as a high constant node in the sense because these nodes are low power, low constant, low memory, low bandwidth will be there. So therefore, these nodes are high constant nodes in terms of physical size, according to the Bell's law. As the size is decreasing, the computation power is increasing. So though the device's limited size is there, then CPU power is also limited, processing power is limited, then memory is limited because only very few tens of kilobytes will be there, where it can be stored only few. Bandwidth is also limited, only 256 kilobytes per second, which you can have it. Low data rate because there is a low data rate in these devices, and the power consumption is a very critical here, right? In these devices, if you take Bluetooth, if you take Zigbee, or if you take sensors, definitely the power consumption is a very critical, and we need to address the power consumption problem very effectively, especially in the Internet of Things. Okay? And because of these constant nodes, when you are connecting to the internet, definitely internet is going to is a resource hungry. Internet will consume a lot of resources. The things are definitely we are going to have a resource constant, energy constant devices. So therefore, there is the incompatibility is there between the Internet of Things as in the Internet plus things. Then the third category, which we are going to with the help of these things, it raises. See now when we talk about the things, it ranges from small sensors to a large general devices, big machine, giant machines we can have. Now it can be range from very small sensors we can connect it, and then through general devices it can be a refrigerator, it can be a smart TV, it can be a machines in steel plant, or it can be some right. All the devices will be communicating, machine to machine communication is going to happen. Right now, when we see when we call them as why we are interested with it, because the edge devices which we are going to talk, we will try to see the edge devices are nothing but the smart devices, intelligent devices. They are of course they are electronic device. They are going to interact interactively, autonomously, and intelligently. They are going to process it. Right, whenever I want the data, just I'll get these things, right? So therefore they are going to have interactively, autonomously, and intelligently they are going to process the data. Suppose for example, whenever the mobile device enters into the proximity of this refrigerator, refrigerator will send the Benson message to the mobile. Now mobile will act as a mobile gateway, then like a message that don't forget to buy a milk, right, to buy the milk. So immediately it will send the message to the information, and then through the app the user is going to handle the situation very intelligently. So because then people were talking about right when we talk about IoT, this instrument, interconnect, and intelligent process with them, right? So nowadays people were talking about the smart in the sense we are going to find quickly and we are going to delegate for appropriate decision making. So because of this smartness, because of the new smartness, people were talking about smart grid, smart meters, smart cars, smart homes, smart cities, and many smart in the rest. Because for efficient decision making, we are going to use this smartness. Okay. And the third category is the data, because as you already know that the data is going to generate the data which you are going to use. It is going to generate huge volume of data. Huge volume of data. Now that data need to be transmitted using the internet, and we need to store somewhere else, right? So that is all about internet plus things plus data. Now, if you have any doubts, please let me know, sir, up to this before I go to the internal details of this IoT architecture. If anyone have doubts, please let me know.
So based on yes, all the participants are requested to, if there any doubt, you can write down on the chat box, or you can directly ask to the speakers. right now, there is no doubt, sir. You can go ahead.
Yeah, I'll proceed. Right now, right, when we talk about IoT with the three different components, it is not that much easy handling internet, handling different types of devices of heterogeneity, and we are going to get different types of data models from different devices. Handling this thing is not that much easy. Though we are having IoT is a very simple word we can say, but the challenges are very complex. Whatever the challenges we have, like it's a real-time data, it is going to be generated, and then intelligence will come into the picture. Distributed in nature is going to come into the picture. Security and privacy is going to have, which you're going to have it. Right, all these things which you're going to have it. Even the architecture is a very complex architecture. We cannot handle. I mean, we cannot have a single architecture like computer network has a single architecture, right? No, we need to have a stack of different architectures. Now we'll try to see the IoT architectures where where different components will come into the picture. The devices will come into the picture. The gateway will come into the picture, and different types of hardware, IoT platforms will come into the picture. Okay. Now we'll try to see the IoT architecture.
Sir, hello. There is some low audio from your side. Can you put the mic near your face, sir? Yeah.
I think only one or two maybe audio is not possible. Sound problem is. It's audible to the other participants. My voice is low.
From my end, it is okay, but some participants having some issues.
Maybe there are actually some problems there. Yes, audio is perfect.
Yes, sir.
Yeah, it is perfect. Audio is perfect.
Okay.
Thank you.
Thank you for your response. Okay, sir.
Thank
no
you.
issues.
Yeah. Maybe their network problem will be there, sir.
Yeah.
Now, what is the need of IoT architecture in the sense? Because as you know that it's a very complex ecosystem. If you've seen, when we talk about IoT requires cloud computing. IoT requires big data processing. IoT requires big data analytics. IoT required artificial intelligence concepts. IoT requires 5G. IoT requires wireless sensor network. So therefore, when we see here, so many things will come into the pictures, like sensors will be there. Networking capabilities means we need to have both the legacy networks as well as the wireless networks we can have, and the cloud computing features will be there. Applications, various applications where we can use IoT. IoT can be used anywhere. So therefore, various types of applications will come into the picture. We need to have different types of protocols need to be there, and hardware need to be there, right? Different types of hardware, different types of software. Definitely, all these things, if I want to integrate as one ecosystem, definitely we require what? Overall plan. Now, overall plan requires the IoT requires an architecture. So therefore, we need to go through the architecture in detail. So there are so many architectures for there. I'm taking the one proper architecture. If you go through ESTI, European Standard Telecommunication Institute, ESTI is there, ITU is there. They have proposed different types of architecture, or Internet Acceleration Board is there. They proposed a new architecture. But I'm referring a reference model or architecture called IWF, means IoT World Reference Model. They have given a little bit of flexibility like your TCP/IP reference model. Anyone is there who has not known computer network in this? The faculty who doesn't know some knowledge on networks? Anyone is there? You can put in the chat box. Anyone is there who are not known networks concept? Okay, I think everyone known it, no problem. So if you are already comfortable with computer network concepts, then what we'll do is you are going to have two ends. One is called as the edge end. This one is the edge end, and this one is the center end. And this one will come under the traditional IT. We call them as a traditional IT infrastructure. And this is nothing but an IoT, which we are going to call them as. Right? That's why this is a IoT and this is a IT. And then, which is a 7-layer model. We are breakdowning this reference model into a 7-layer model. Starting from the edge level. Edge level is mainly on the physical devices and controllers. Will control from vertically. We'll try to control various sensor devices will come into the picture, whereas RFID tags will come into the picture. RFID based sensor devices will come into the picture. Zigbee devices will come into the picture. Bluetooth devices will come into the picture. Bluetooth low devices will come into the picture. So therefore, there are so many devices will come into the picture depending upon the application specific. The next one is the internet connectivity, which you are going to see. Now here we are going to use both wired networks as well as wireless networks. Again, we are going to connect to so many things are there. Again, the 5G will come into the picture here. We are with short range communication as well as the long range communication. We are going to use it. Now, in traditional IT, what is the problem is now, for example, now I'm dumping the whole data to you. Suppose, for example, from last 5 to 10 minutes, what I did in the sense, I'm dumping huge amount of information. Now, question comes to whether you're able to store all the information. That's the question. Now, we are unable to store, sir. Please send the PPTs or please send some video recording so that we can revise. Few participants will ask that we want to have some. So immediately, what the coordinator will do, he will start recording the information at the edge level, and immediately he will send to the cloud. He will send to the cloud through some Google Drive. So what is happening in the sense, because whatever the data it is coming from the sensor devices from me, I unable to handle. Right? You cannot handle all the information whatever I'm giving. So you want some time to repeat those data. So therefore here in traditional IT, what is happening? We are going to use. We cannot store everything whatever we are going to send to the cloud. So we are going to use an interesting one called edge computing and fog computing. Right, which you're going to see. This Cisco was introduced in 2012, and we are enjoying the fruits, which is also called as a distributed cloud here, or we can call them as a fog cloud. And then the data accumulation is called as a cloud computing, where we can store the data. And data abstraction, we need to apply some DBMS, data mining, and big data analytics problem for data accessing and data abstraction will be done. And then which we are going to use applications for reporting and analysis. And then finally, we are going to use the collaboration and the process level which you're going to have. Now, whatever we are having, the data which is coming from these devices are nothing but data in motion. They are real-time data. The sensor data is nothing but a real-time data. We are converting that network flow into information by using some analytics there. We can call them as what? The data at rest, it will be converted from real-time to non-real-time data. And here, the information from the traditional IT which is coming, it is a query based. That query based will be converted into event based, right? The query based will be converted into event based, and then event based will be converted into query based. Now, this we are having a clear distinction between a clear bridging is required between the IT as well as the OT. Okay, so we'll try to study one after the other in detail about these devices. Now, when we see the edge nodes, and then the connectivity will come into the picture, edge computing will come into the picture, cloud computing will come into the picture, data abstraction means big data analytics, mining, DBMS principles will come into the picture, then application will come into the picture, and then collaboration as well as the process will come into the picture. Now, we are going to have a clear separation, as already you know that now we are here. Up to now, the traditional IT is all about this one. We are using a lot of databases, we are using a lot of servers, we are using a lot of cloud stuff which we are going to store it. So therefore, this is the traditional IT. Now we are in this one, the IOT, which is a real-time, which is a distributed data, where the network will be used a lot of things, and everything is event-based now, right? So which is we need to have a clear bridging between the OT as well as the IT. Right. So therefore, if you see IoT, actually, someone has discussed, I don't know, it's a 4-layer model, it's a process. IoT is IoT of everything. What is that? First, things will be there. Next, things will generate the data. We need to process that data that we got. And then we need to take appropriate decision making for those data. So we have devices, we have things, devices and sensors at the edge level. Then through network connectivity, through some 5G or 4G or 3G, whatever we call them as, we are going to have two types of things. One is a short range communication. We can also call as a local area network. We can use something like a Zigbee can be used, a 6LoWPAN can be used, or some Ethernet can be used, Wi-Fi can be used there. And then through wide area connectivity, which will be connected through internet, which we can call them as, right? Through internet, we are going to send to the cloud. Now, my question to all the participants, where we require ML? Where we require ML? Anyone can give the answer here? Just a question I want to pose to you. Where we require AI or ML in this architecture? So let's have an interactive session so that it will be there. Yes, at the cloud level, very good. Very good.
For data analytics.
Yeah, are they for data analytics where we require cloud? Yes, we require ML. Yes. Application, yes, we require ML. Very good. Yes, definitely. Very good answer. ML and AI can be used in edge computing. See, in each and every level, we require ML. If you want to take the division at the edge level to access intelligent device, if the device want to be an intelligent device, definitely we need to apply some learning algorithms, machine learning, hardware learning algorithms at edge level. We can use it, and because we need to filter the data, we need to evaluate the data, we need to process the data, we need to aggregate the data, which we are going to use the edge computing. Then at the cloud level, once it is stored, because different type of data, and the data is going to land at different places, we need to have some clear separations. In all the levels, we need to have this ML and all these things. So it's a very challenging. Now, applying this ML in IoT is a very new area and very challenging area. Actually, of course, the ML they are using a lot in the industrial IoT nowadays. Okay. Now, first we'll try to see, as already told you, different types of devices which we can have. The sensor devices we can have. The best example which we can see the beauty of the sensor devices. Now, if you take fast tag, the government of India introduced the concept of fast tagging system, right, which is purely based upon RFID tags concepts, which is also what we have as a CC surveillance will be there, right? We have home automation devices will be there. We have chain machines will be there where we be connected. So the main purpose of these physical devices and physical controllers are nothing but to have the analog to digital conversion is required, and it is going to generate huge work generating the data. That's the next important parameter, and then being queried and controlled over a network, right, which is going to be used as how we are going to be controlled, because whenever queries happen, suppose for example I want to know the temperature at 11 o'clock, what is happening in Gujarat. Right, by sitting here, I want to monitor, and my sensors will be. I'm going to send a query at the Gujarat. Then I'm going to get the temperature at 11 o'clock, something like that, or some alert messages when the temperature is reaching 45 degrees. Then immediately I should get an alert through some devices, and it should alert the human beings. Yes, above the temperature is above 45. Please be very careful. So we need to have a query based as well as control over a network need to be ensured, and that will be the physical devices as well as the physical controls. Right. The next one is the connectivity level, which we are going to see. The connectivity level is mainly concentrating on that. Now, you should have a strong knowledge on networks or internet, where we need to have a communication between level one. Level one is nothing but physical devices, which we are going to connect it, either in terms of short-term communication as well as the long-term communication. Like, so reliable delivery across the network. Across the network, we need to ensure. Next one is implementation of various protocols need to be there. Now we need to apply not only networking protocols, but also we need to apply the machine learning algorithms here. Then we need to have a switching and routing. The ML routing mechanisms is required to make appropriate decision making. Now this is very important. Now actually routing up to now, routing doesn't have ML algorithms, though the research was going on ML using on routing mechanisms to make appropriate mechanism to divert, to minimize the congestion, to minimize the traffic. The ML algorithms need to be applied at the routing level as well as the searching level. Then translation between the protocols means even ML can be applied at the gateway level to make the appropriate translation between the protocols. What is the need of gateway, sir? Anyone can give the answer. Gateway. It's a communication. No, some other technically gateway.
Because these devices are not compatible to each other, we may need some sort of interface where they can communicate properly.
Yeah, very good. See, now that's why, because for example, the legacy devices makes use of IPv4, all right? Or some devices doesn't know about, like if you take 802.15.4 personal area network like Zigbee. Now, these devices makes use of IPv6. Now, we need to have, because IPv4 address, the 802.15.4 doesn't know about IPv4 address, and even your Wi-Fi it makes use of both IPv6. So, someone should be there to make the translation to convert it from IPv4 to IPv6 and IPv6 to IPv4. The translation need to be there. So therefore, gateway is a 5-layer model. It can understand all the layers in detail. So therefore, yes, very good. NAT, network address translation. Unfortunately, IoT doesn't. There is a problem with the scalability with NAT. Network address translation, there is a problem with NAT. Network address translation scalability is a major problem. It cannot because it cannot handle the scalability issue. It cannot handle effectively of the security issue. The address translation. Of course, the gateway is something like we can use a NAT gateway, but the NAT is not applicable, especially to that. Instead of that, they're using SDN, software defined radio, at the gateway level, which you are going to segregate. And the security at the network layer will need to be there. Network security need to be there, which will be taken care of as well. And as I already told you, self-learning network analytics should be done here. The network layer also, we need to apply the machine learning algorithms here, where we can use it. Okay. I think you're already comfortable with machine learning algorithms. I need not to. I'll give in the maybe what different types of machine learning algorithms can be used. All right. The next one is the edge computing level. Now, I want to give a brief introduction about this edge computing or fog computing, which is a little bit interesting and new concept, which is a very important one in IoT. Now, we are making the processing. We are reducing the traffic. Now, global traffic need to be reduced. Now, congestion need to be reduced, and we need to filter the data. We need to send only the essential data which is required, and we are going to store to the cloud. Suppose, for example, I'm in my class, I'm giving some unnecessary data. I think for few intellectuals, those unnecessary data is not required. So what they will do, they'll mute it. Okay, he's giving some unnecessary where I already know it, right? So what is that? You are filtering rather than storing your because you are saving your energy. You're saving your energy, and wherever the essential component is come, then you're going to unmute it, and then you're going to listen it, right? So what we are doing, because we need to save the energy, we need to save the traffic, global traffic, because global traffic is going to happen. So at this one, the third level will play a very, very important role, where the edge computing will come into the picture, and edge cloud will come into the picture. Okay, we'll try to see. That's the edge. Neeraj sir,
Nayo bro. Nakmat nakyo.
Yes, sir. Continue, sir.
Yeah, we are going to generate a huge volume of data, huge amount of data. See, now the question comes to you, the devices will generate the data faster than the IT side, traditional IT, and it can ingest it. Now, the question comes to you, ingest in the sense that whatever the data, suppose for example, now I'm a little bit fast now, 1 or 2 slides, I will be a little bit fast. Now, at the receiver side, at storage side, it will, now I will get a comments in chat box, sir, you're a little bit fast, please slow down. Right? So what is happening here? Please do slow down, because I'm unable to handle your fastness. So here the real-time data, whatever it is getting from the various sensor devices, now it is very difficult to store those data into the cloud. That's a major problem here. Not capable of performing the real-time data analysis and feedback in the traditional IT sector. So for that, now this is a major challenge which we are going to have it here in the sense. Now, if you say, for example, an airplane will generate multiple terabytes of data per hour, multiple terabytes of data. And those terabytes of the data, if you want to store into the cloud, it is not possible through internet, right? It's not at all possible to the internet. Or say, so that's why storing all the data permanently in the storage is a big problem, and sending to the IoT applications is the biggest challenge. And if you take another instance like cars, when we use vehicle-to-vehicle communication, right? When we are using a vehicle-to-vehicle communication, and then the car is going to generate even the terabytes, even some you can take gigabytes of data per second or per minute, whatever we can call them as, and those data need to be sent to the cloud, where the cloud will be somewhere at the data center where we need to store for efficient decision making, where it is not possible. So this is the major problem with the issues with the traditional. So to overcome this problem, the possible solutions that Cisco and some other companies they started uses like in the open IoT framework. In the devices level, we use various types of protocols. We can use it, and we are going to use edge software. These edge software have the capability of storing the data, like OT data. We can use some machine learning algorithms. Some analytics can be done for we are filtering the data. We are evaluating the data. We are segregating the data. We are going to minimize the data by using the abstraction APIs will be there. And then data collection and proxy and streaming inserts can be sent. The OT data will be sent to the cloud next level, right? And then this is the OT data, and this is the IT data, which is going to happen through some data integration and virtualization mechanisms. I can use either application level as well as the analytics level, and then we are going to use the business decisions can be happen. Okay. So that's a challenging issue which we are going to use it. Now, what is that? How to minimize the data is the challenge. We are going to get the data from the different sensors or from different devices. We are going to use the metadata before sending this data to the cloud. We are sending this data to the cloud. We call them as a what? Metadata. Right. Now, see the role of big data and AI in IoT, where we required the role of big data and AI. Now here, which we are going to use it, we are going to use it is what here in the sense we are using is a fog computing, we are using cloud computing, we are using big data here, and then after that AI can be used here, right? Now the next one is AI is very important component in IoT, which we are going to use it here in the sense. Right, if you see, the AI can be used at the edge computing, the AI can be used at the edge level, fog level. We can use big data can be used at the cloud level, and then AI can be used at the data analysis level. So appropriate solutions we can use the AI as well as the machine learning algorithms. So what we can say now, our main motto, the need of fog computing in the sense we are converting from millions of nodes to tens of hundreds of devices. So the devices we are expecting, we call them as the edge coordinators. Which you will do. Thousands of coordinators will be there through internet, and then cloud data centers will be there, hundreds of devices. So therefore, we are using the need of fog.
Yes,
now, yes, sir. Hello.
Yes, sir. Yes, sir. Continue, sir.
Yes. Thank you. Now, what is happening in traditional IT? The data will be processed at somewhere at the cloud level. Analytics can be done in the traditional IT. Now, whatever the data which is coming, we are dumping the data. That's another. Now, if you see this mechanism, which we're going to use it here in the cloud, in the edge computing level, we are going to use what? Data filtering will be done, data cleanup will be done, data aggregation is going to be done, packet content inspection is going to be done. The combination of network and data analytics will be done, right? And event generation will be done. So we are converting data packets and to information understandable, and then we are going to store it to the cloud. So therefore, it is something like now whatever we sold. Suppose, for example, human beings are there. Now your fog is nothing but your brain will work like a fog computing. First we'll listen it, and then we'll store back to the cloud permanently into the cloud level, right? So your brain will work like a fog computing as well as the edge computing, as well as the cloud computing level. Okay. Right. So how it is going to happen in the sense, because the census data will be generated to the data, we call them as the edge node, and the edge node will give the data to the fog node, and the fog node will give the data to the cloud, right? And then the processing can be done processing can be done at the edge level, at the fog level, as well as at the cloud. So 3 levels of processing can be done in the IoT data processing. So therefore, IoT is going to give as a new computing era or new computing. Now, this is the way of the IoT edge processing need to be done. What we are going to do is nothing but, in the sense, the filter, and we are going to evaluate the data, and then we are going to have the transform into standard format or canonical format, we can call them as, and format of a specific target which is required. We are going to store at the data centers, and then we are going to we are sending to the cloud, where it will have sent to this one. Means backend data sharing can be possible from here to the other clouds. Now, how can we use this IoT data via fog computing instance? See, if you see, these are the edge nodes. These are the edge nodes we can have, and this is a mobile node. It can be a fog nodes. These are the fog nodes which can be sent, and this is the data center which we can send, and then we can send to the data center to any cloud, or it can be a cloud or to the internet, right? Before I go to this topic, if you have any doubts, please let me know. Data accumulation. Before I go to the data accumulation, you have any doubts? Go. No other doubts then? Yeah, I'm audible. No one is responding. See, if doubt is there, yes, sir. Try to send something, yes or no, because in online, what is happening is only
Yes,
one way.
sir. Yes, sir.
Yes, yes. If you have doubts, means if you have yes, means you can ask me. Otherwise, you tell no something, so that I can. Because sitting here, I don't know whether the participants will be there or not. Okay, right. If you have no doubts, then okay. Then thank you. Right. Then the next one is the data accumulation or data storage. We call them as the cloud computing, which you're going to use it. Once the filtering and once the evaluating the data, once the aggregating the data, then we need to send to the data accumulation, which is data storage, cloud storage. So what is that here now? But what we are doing in the sense here, in the sense we are going to convert the data in motion to data in rest. We are converting a real-time data into non-real-time. It is in the rest. And we are converting the format of network packets into relational databases, right? We are converting into the relational database, and we are achieving the translation from event-based, from OT to query-based computing, right? And it is we are going to reduce the data through filtering and selective storage because it is coming from the fog computing or from the edge computing nodes. So therefore, this level is something like a cloud level where the traditional IT will come into the picture. Okay. The next one is the data abstraction level, which we are going to use it. Analytics can be done and machine learning can be done. So therefore, what this data abstraction level will be there, we are going to create the schemas and the views of the data in the manner that the application wants. Because for further decision making, whatever we are doing, now application want the real-time data, and then that data should be useful for valuable insights, for valuable decision making. So what is going to happen is, because the data should be available ready, and we need to process the data, we need to analyze the data, and then it should be ready to the end user, to the end user application to make further decision making. So what we are doing here, we are making ready to the end users. So therefore, create the schema and views of the data in the manner that the application wants. We are going to combine the data from multiple sources, because the data cannot be stored cannot land at one data center. It will be stored at different places. So therefore, combining the data from multiple sources and simplifying the application. Then again, once again, we are going to do second level of filtering, selecting, projecting, and reformatting the data to serve the client application. Right? Integrating reconciles the difference in data shapes, different formats, semantics, interoperability should be there, and access control as well as the security need to be provided at the data abstraction level. So this is the responsibility of the data abstraction level, which is going to happen for appropriate data aggregation as well as data access. Okay. Now this is the way which I already told you. See, this is happening here in this way, and then it is stored, and then even if you can send to the application by requesting and as well as reply, or we can do with the analytics as well as with we can process. This is abstraction API between the data as well as the application. The next one is the application level, right? Now we are going to see an interesting level in the applications which we're going to use it here in the sense. In the application level, which is a very important one, because we do have different types of applications. Now, my question to you: where we can use IoT? In which area IoT can be used? In which area the IoT can be used? Almost all. Very good. It can be used in everywhere. So, if it can be used in anywhere, means in different types of applications we can use. Depending upon the applications, we are going to use different types of sensors, right? So therefore, what we can have, sometimes we need to control certain applications. We can have mobile applications, we can have some business intelligence BI, or we need to have some analytics can be done everywhere. So therefore, when we start seeing these applications, when we have some applications will focus on monitoring the devices. Some applications will be focused on controlling devices. Some will be combined both the device and non-device data. Some is going to handle the mobile applications. So therefore, whatever we are going to have it up to level 5 or level 5, it is all about the different type of data, the data storage, data analysis, data processing. Now, depending upon the requirement, we are going to use these applications, and then the different applications they use this data for efficient decision making. Yes, sir. Yes, sir. And yes, we can use in healthcare, finance, and smart cities. Endless. Very good answer. Right now, let me give clarity about this reference model. I think if you are unable to follow, then this model will give a clarity to you. Now, when we see this one, when we have a devices, then these devices will be connected with the connectivity, and then we can filter and we can evaluate the data in the form of edge computing. And then after evaluating the data, we can store into the cloud. We call them as the data storage or data accumulated. And then we are going to aggregate, we are going to make it some processing, combining from different sources of data. We can call them as the data abstraction, which we can call them as, and then the applications will be used. And then finally, we are going to act and collaborate. The act and collaboration is going to happen. So this is an example of IWF reference model, which is and this reference model is an annual event which is conducted yearly wise, and major legend companies like Cisco, like Intel, Qualcomm, IBM, they are part of that. R&D organizations are part of that. ITV is a part of that to provide this reference model. They have given a lot of industry-oriented reference model. Okay. Now, if you see this architecture model, which is going to have it. Now, if you have this is a wireless sensor network, which call them as a Zigbee PON coordinator, and it is connected to the Zigbee coordinator. Zigbee coordinator can be a fog node, which will be connected to the master server aggregator, which we can aggregate the data and we can store somewhere at the fog computing, and we can evaluate the data. And then through internet connectivity, through LTE or through Ethernet, through Wi-Fi, I'm going to send to the cloud. And then we are going to perform the analysis, which you can call the big data analytics can be done. And then finally, application user is going to happen. Like this, we can have n number of networks at the edge level. Different types of devices may be there at the edge level, which we can do. So these are edge devices. These are the fog devices. There's a network connectivity. We call them as, again, network connectivity are of two types. One is local connectivity and as well as wide area connectivity. And then cloud infrastructure. And then we are going to have the big data analytics. and then which we are going to have the applications. So these are the different models where we can use in reality of IoT. I already go back. If you have any doubts, sir, please let me know. Gautam sir, shall I continue or we'll have a break because 1 hour, I think.
So, if you want, we can take the 5-minute break. Otherwise, we can continue, sir.
No, I want to ask because I can inject it, but the participants 1 hour, no, but we'll have a break or we'll.
This session for the 2 hours, 9 to 11.
Yeah, I know it. That's why that 2 hours continuously, whether they can sit or not, that's a question.
Okay, sir.
Therefore,
We will take the 5-minute break, sir.
yes. Before
Maybe,
break, if any doubts, please let me know. Before we go to the internal architecture of IoT, how architecture can be implemented, how machine learning algorithms can be implemented. Any doubts? Okay, if there are no doubts are there, then we'll have a break for 5 minutes and then we'll join around now. What is the time, I think?
it is 10:05.
10 files will start session 5 minutes. Okay, thank you. Gautam sir, shall I start?
Yes, sir. Yes, sir.
Yeah, thank you, sir. I think there is one. What are the research areas of in IoT? Yes, there are so many research areas because it's a very new area. If you want to do something like a research integrating of the cloud with IoT, that's one of the research area. Or fog and cloud in integrating is another research area. And the fog with wireless sensor network is another research area. Performing the big data analytics is another research area. Then ML with applying the machine learning algorithm throughout the various levels is another research area is there, and security and privacy at each and every level is another research area. So there are so many areas are there where we can apply. A lot of potential is there. You can start working on this problem. Bharat, sir, I think you got this, sir. All right. Sharma sir, what you want? Do you want to see something?
Sir, I just wanted to see that slide, previous slide.
This one?
No, the one on edge computing devices and fog computing devices.
Yeah. 1 minute. Yeah, this one. You have any doubts here, sir?
No, previous to this, sir, where it was mentioned border router, Bluetooth hub, ZigBee coordinator, all those.
Oh, that one. Yeah. 1 minute. That one. You want over? Yeah, this one.
Yeah, this one.
Yes. Do you have any doubt regarding this slide, sir?
No, sir.
Yes, sir. Okay. Right. Now, this is a way because we are going to connect different heterogeneity of devices which we can be connected. Heterogeneity of devices, we can use it. And then these devices will be connected to the different types of devices which you're going to have. Okay. Right. Then quickly we'll try to go to the yeah.
What is this SWAP, sir?
That's SWAP is for software defined radio application service points will be there, sir.
Okay.
Software defined networks can be directly they are connecting to the edge router. Right. Now, oh, sorry, I actually. Now, see here, now to implement such things, because it's a big ecosystem and multiple technologies will be the part of the IoT, which we're going to have it. Multiple technologies will come into the picture. The protocol architecture of IoT will be there. So therefore, we'll try to integrate the 7-layer model into some implementation part, which we're going to see. That we call this for 7-layer models as a 5-layer model as a business perspective. One is the objects, which we call them as the RFID sensors will come into the picture, and then we call them object abstraction, which is called as a connectivity, and then we call them as a service management, like edge computing, fog computing, big data analytics, right, machine learning or nothing but service oriented, and then we have an application layer, and then finally we have a business layer. And finally, we have a business layer, right? Now, these layers of object and object abstractions are called as what? In the sense, it is called as the infrastructure protocols. It is called as the infrastructure protocols. And then next one is the service management, which we call them as the service discovery protocols, which is a very important. Now, for example, I want to know for here 111 members are there. Now I want to know Gautam's IP address. So I don't know name. I know only the name. Name is Gautam sir, but I don't know what is the IP address and what is the MAC address he's using. So what I'm going to say, I'm going to discover. I'm going to provide a discovery. So I want to ask something to the Gautam sir, some facility. I want to take some resources from the Gautam sir. So what is going to happen in the sense? I want to have some service discovery. I'm going to broadcast a Benson message to all the members. The name is Gautam. Gautam sir, right? And then I want the IP address of that Gautam sir. So therefore, we are going to use a multicast domain name service. We call them as some multicast domain service is there. Domain name service, service discovery is there. Simple service discovery mechanisms are there. So the upper layer user, what is going to use it is going to identify. You want to identify certain devices in the form of service discovery. So service discovery should be done at the middleware layer. Service discovery should be done at the network layer. And then we are going to take the appropriate decision making, right? And then we are going to use this one called application layer, which we are going to see the application layer protocols. Okay. Now this is the integration of a different wireless sensor network and internet. We have a TCP/IP, which is a 5-layer model, and then this is a Wi-Fi stack example. We have a Wi-Fi, which is a network technology, which has a 2-layer model. It's a 2-layer model. It has a physical layer and data link layer. We have. And then IP layer will be there, TCP and HTTP will be there. But IoT has a little bit different because what is the question I asked? Because the devices are high constraint node. What is the meaning of that high constraint node? Which I already told you. What is the meaning of high constraint nodes? Anyone? I told you internet plus things plus data, no? What are the things are of? Now, usually the things are of actually high constraint nodes because their frame size, their packet size is small, right? The processing is limited, their bandwidth is limited, right? Their power consumptions are there. So therefore, the packet handling by the 802.15.4, we call them as either Zigbee or it can be a Bluetooth 802.15.1. Their packet sizes are maybe maximum is 64 bits. Now, if you take only internet IPv6 address is 128 bit. So therefore, what about the payload which you are sending? So definitely it is very difficult to handle. So IoT has an interesting layer called adaptation layer. We call them as a 6-LoWPAN layer, which we're going to call them as a 6-LoWPAN layer, IPv6 low power personal area network. Low power personal area network. All right. This is an adaptation layer where it will do a lot of fragmentation, a lot of compression mechanisms, which is required to the high constraint nodes. And then we have a routing protocol. Like there's so many routing protocols are there in traditional networks like Zigbee, broader router, broader gateway routing protocol is there, and then distance vector routing protocol is there, link state routing protocol is there, right? There's so many protocols are there. Like internet, they have standardized by IETF by proposing a routing protocol for low power and lossy networks. RPL stands for what? Routing protocol for low power and lossy networks, and we are using the rich facilities of IPv6. Okay. And the next one is the TCP. Unfortunately, we are not using TCP because of the handshaking mechanisms, because of the underlying mechanisms of TCP, which is not suitable for the IoT. They're using for UDP, right? They're using for UDP, which is working on that. And we are using two popular application layer protocols called MQTT, message queuing at telemetry transport protocol. We can call them as transport protocol, and the COAP, constant application protocol, which we're going to use, right? Two standard protocols which we're going to use. Now, if you see here from the application users, from the application to the UDP and through IPv6, so LoWPAN to 802.15.4, and then to traditional internet domain, it has been connected. To the traditional internet domain, it has been connected. Okay. Now, this is the two-way which is going to happen, two-way communication which is going to happen here. In the sense, you can have an Arduino kit here. We have an Arduino kit, we have a Raspberry Pi kit, we have a mobile field communication, we have a Bluetooth low energy, we have a MQTT sensor network, MQTT sensor network, which is used. We have a Zigbee network, right? This is the this is the network technology which we're going to have. This network technology is to be connected to the internet, which we're going to call them as to the internet through the internet protocols, which we call them as either TCP or UV, like bus topology or Wi-Fi or gateway, which we're going to use it. And then through cloud services, which we're going to use it through the cloud services, through which is a service discovery protocols, which we're going to call them as. Then finally, application layer protocols, which we're going to use. Okay, now this a sensor RFID based sensors. You take it this Zigbee network. This is a Zigbee network, and this is a 6-LoWPAN network, which we can have. And this is the RFID reader where it will read the tags, and this is the sensor gateway or the reader, which is taking this one. And through IoT gateway, we are going to connect it to the internet. Through the IoT gateway, we are connected to the internet, and through internet, we can store it into the cloud. So therefore, this is a RFID Arduino RFID tags, which is a sensor-based RFID, which we're going to have it, and then active tags, which we're going to have it. And these tags may have some sensors that can be connected with 802.15.4 physical radio frequency system. Radio frequency system, which we have. So this is the way of RFID sensor-based system can be connected to the IoT. Now, what the IoT is giving, as you already know, that IoT is going to generate the data. So therefore, definitely we can say the data is a new oil, which is going to happen, right? Which we are going to see. The data will be a new oil. Now, what is going to see here? Now, any business or the businesses are willing to share their most valuable assets. That's the next one. They are willing to share whether the data, the valuable data. Now, I'm willing to share my PPTs. That's a question now. Right, or the coordinator is willing to send the slides, or the coordinator is willing to allow you So therefore, we need to have from business to business logic, whatever the intelligence, whether they are willing to share the most valuable assets. That's the question. That's a challenging question we have. So therefore, what we are going to see here, data will be a new soil, which we can say this soil, definitely the soil without a rain is equal to the data without security. The soil without a rain is equal to a data without a security, which you can do. Data without a security. So therefore, what we require is we need to study some of the challenges. We need to study some of the challenges where it is very much essential. Okay, that we are going to see. Now, what are the challenges or key requirement for any IoT platform to scale well? Yes, MQTT makes use of TCP, whereas COAP makes use of the UDP. Chinmay, yes, I think you got it. MQTT is already proved one. They're working on top of the TCP, whereas COAP, Constant Application Protocol, makes use of UDP. Right, both are standardized mechanisms. So therefore, what we'll say is, right, we are going to have the scalability, because IoT is known for to handle some millions of devices, and IoT is going to generate real-time data. We need to have the valuable insights from that real-time data. And when we talk about the edge intelligent devices, they are intelligent and dynamic in nature, which you can call them as, and they are decentralized and distributed in nature. So the success of this IoT is purely depends upon one of the important parameter called the security and privacy. The security and the privacy which you do. So what is the challenge here in this sense? Because now the devices which we are going to see, they are very tiny in nature. They're easily theftable. The IP can be theft. The data can be theft. So therefore, the data identity theft can be happen here comparatively. Right, data device manipulation can be done very easily. Once I get the, like you can see, I'll come to know in my slides, like a Mirai botnet attack is there, and that data falsification is going to happen, and then IP theft and server or network manipulation is going to happen, which is a very challenging, because the success of IoT is mainly depends upon the various factors of these security issues we need to be addressed. Now we'll try to see a new area, which though we are going to see the technologies are giving a lot of flexibility to us. At the same time, there are different types of attacks for them. Now IoT is also called as Internet of Threats. So we call them as a Internet of Attacks are there, right? We call them as the Internet of Attacks, which we can call them as. So therefore, which we are going to see interesting point of. Right, if you see, though the new opportunities were created, but there are very more chances are there to exploit the weaknesses of those data and to get a gain. For that, what we are going to see here, in the sense, if you see data breaches which are happening in the investigation report, which is going to happen, that if you see from the data breaches, which right, and it will be forever. These data breaches will be forever. We can say we cannot. If we eliminate one, we'll get new one. The data breaches will be forever. And this is the investigation report which is happening year by year. There's so many things. So last to know that more than 90% of breaches are discovered by the external parties. And what are the passwords? 60%, 63% of the breaches were happening because of the weak or default or stolen passwords. Now, I want to ask a simple question. How many people are using your Wi-Fi router? You have changed your passwords in the Wi-Fi router? Or mobile hotspot, how many people have changed? Because
Very rarely, sir.
Yes, sir. Yes, sir. Not many times. Usually, we are going to use default password, which is given by the vendor or manufacturer, isn't it? So therefore, definitely they are more vulnerable. They are more vulnerable if you start using if you are not frequently changing those passwords. So we require some machine learning algorithms here. We need to have some intelligence system to make it very efficient. So therefore, we are thinking of. I mean, the research we're thinking about. I think one of the participants asked about one of the research area of IoT. Machine learning security for IoT can be applied there. Okay. Because machine learning security is going to provide a dynamic security, which is one of the interesting one. Okay. So therefore, the data breaches are happening in various sectors like manufacturing, public, professional, information, utilities, transportation, which we call them as education sector, real estate, financial service. So in all the sectors, the data breaches were happening. Right? If you see in manufacturing sector, so therefore, the people confidence or people faith definitely on various various products, the confidence levels will be very low because of the if you see. I don't want to say in the online, but when we go for some the production with Apple compared to the China models, the security level is a little bit low. They're easily compromised, right? There's a low, the security is very apps of the China which is banned by the government of India. When we see such type of mechanisms, because security breaches were more vulnerable because they're going to store all type of data and they're going to analyze those data. So this is a world without security, which is going to happen. Now it is a responsibility of the security developer or the security admin to provide good security policies, good mechanisms for IoT. Now we'll try to see some of the attacks, which is with respect to this one. What are the attacks were happened? Attacks were happening on not only one devices; they are happening in all the devices which have been designed. Anyone heard about Philips Hue bulbs? Philips Hue bulbs. Yeah. So Philips Hue bulbs uses a better security mechanism like AES algorithm they started using. But unfortunately, what is it? They use the same type of key for all the Philips Hue devices. And see what the attacker is exploited. They exploited using side channel attack. They reduce the key. They reduce the key and they are more vulnerable, and all the devices are compromised. The attack what happened on Philips, it's a smart bulb, right? So the attacks are not happening on one devices. The attacks are happening on various devices, maybe 400 to 500 smart devices from 2019 to 2020. The attacks were happening because the malware will be injected. The malware will be injected into one device, and the attacker will exploit the weakness of that, and he will spread from there to a number of devices which is connected over internet. So that's why IoT threat is 72%, and attacks exploit the device vulnerabilities are 41%, which is going to happen and on various things. So user practices were there like crypto hijacking, phishing, password, botnet attack is a distributed denial of service attack, right? Backdoor Trojan attacks, ransomware attack, which is also called as kidnap attack. So there are different types of attacks which are happening in the IoT threats. Now we need to, why I'm telling all these things, because we need to apply some intrusion detection mechanisms, because attacks were happening. We cannot predict because we cannot defend these things because attacks were happening because of the weaknesses that are there in the devices. Now we need to apply the intrusion detection system. Those intrusion detection system can be applied using machine learning algorithms. Why I want to tell on attacks means because we need to apply some machine learning algorithms on the on the data and what is happened and what is going to happen, so that we can eradicate. Sorry. Anyone heard about the Shodan search engine? Anyone heard about Shodan search engine? Key hijacking. Crypto hijacking attack is nothing but key. Taking the keys, sir. Taking the keys of various users. Crypto hijacking attack. Like I told you, Philips Hue bulb is vulnerable to crypto jacking. Now, now all of you, can you type something like Shodan search engine? I'll show you.
Hello, sir. I have a query, sir.
Yeah, please, sir. Please, sir.
So when we work with IoTs, most of the times we use devices like these sensors and all, which are locally available in the market.
Yes, sir.
And because we don't even check whether they have the proper license and so on. Is it possible that these devices will have a chip kind of a thing which will transmit our data to these kind of negative people or something? Is it possible? Because
Of
we
course,
don't
sir.
normally.
Definitely. See, without your involvement, it is not going to happen. Well, the first thing is, suppose, for example, now when you click it, now you have a data, isn't it? Where you have a data which is available in your storage. Any malware has been injected, when you click that data, and the access control will go there, and your data
Yes.
can be snooped.
Yes.
Your data can be snooped, and it is more vulnerable.
Okay.
When we call them as an IoT, see, I say when we talk about security, means security is something like a policies. Every stakeholder
Yes.
or every user should follow those policies. Suppose, for example, don't save your passwords in the Chrome, but still the Chrome will ask you whether you want to save the password. You will say yes. Then, if
Yes.
someone use your laptop or your mobile, the password will be open, your mail will be open, isn't it?
Exactly. Yes. Yes.
Definitely, we need to follow certain policies to eradicate that. Without your involvement, attacks is not going to happen.
Okay. So buying the devices or the sensors locally available in the market for less money or
No, that's
inexpensive.
less security, sir. They are going to have less security. If you take iPhone, and if you take a local China piece model, which is because when we keep less security, less amount, less cost, definitely what is going to happen? Security is compromised there. If you take
Yes.
Apple phone, where security is very good enough because they have
Yes.
their own proper cloud mechanisms, isn't it? So more security and built-in security mechanism is going to happen. Multi-authentication mechanism is going to happen.
Yeah. Thank you, sir. I have one more query.
Sir, please go ahead, sir.
As an IoT programmer, do I have to really worry about the networking concepts?
Yes, definitely. If you want to integrate it, networking concepts is needed, no? But what is that? Already all are customized now. Well, if you take Arduino kit, there are Bluetooth model will be there, Wi-Fi model will be there, right? And you are going to
Yes.
connect it to the internet. That is a one way. But if you want to
Yes.
do anything research in networking, then you should need to have. For
All
application
right.
oriented, required.
Okay. Okay. Thank you, sir. Thank you very much.
Thank you, sir. Thank you. Now we have a showdown. Right now we'll try to see the showdown. Now what I'm going to see, I'll type Bluetooth here. I'll see Bluetooth. Now wherever the Bluetooth is connected, the total information will be visible to you. If you see here, now when I click it, then it's showing in Argentina where the Bluetooth devices is connected to the internet, and then the total information of that devices is going to have it. OpenSSL, that information with the key. They use Mosquito broker with the MQTT connection is going to connect it to that broker, and then even everything information will be available. So once the device is connected to the internet, the total information is available. You can see where this device is there and what is the port number and who is using this one Bluetooth device. Every information is available. Right now, I'll go for CC cameras. Isn't it a CC surveillance camera I want to use? Now, these are the surveillance cameras which you're going to get from all over the world, which is connected to the internet. Now, when we know that, when the devices are known, the attacker is good enough to exploit the weaknesses of those devices, and then they're going to deduce the key, public key of these devices. So this is the key, public key of these devices, and this is the signature algorithm they've used. And then this is the IP camera where they are used with the various interfaces. And then once they know, even the MAC address, once we know the MAC address and IP address, it is very difficult, very easy to enter into the system, right? So this is a Shodan search engine where the attacker can exploit some certain weaknesses. You can see it also. You got it, sir?
Yes, sir. Yes, sir.
Yeah. Now this is the Shodan search engine where we can get a number of information of this one. We get whatever the things. Now what is happening from that, from the Shodan, if we go to dig at it, but I'll not show you because it's an unethical thing, showing all these things, because ethical hacking we can learn it, but showing on the online sites is very difficult. Now username and password information and privileges, everything we can see it. All the Shodan will give the information of what type of password, what type of username, and what is the admin name, and what is the privileges it is going to have. So all the devices which we can see using the Shodan search engine. Right. The other attack which we're going to call them as, I think you have already seen. I think I don't know. Anyone has seen the picture called iRobo picture? iRobo. I think youngsters maybe you have seen. I think a few members you can see. There is the English movie called iRobo, or I think you heard about the Rajinikanth movie. Rajinikanth Robo picture, Robo 1, Robo 2. Yeah. Sir, Ranjan sir, which movie you have seen? iRobo English movie you have seen? Both. Right. Now I want to know something like because most of the participants, I think they have not seen. I think, can you tell about the picture of iRobo, how it is working? What is the main role of that picture? Can just 1 or 2 minutes you can elaborate it so that other person will come to know. It is nothing but a distributed denial of service attack.
Yes, in iRobot, it's a Hollywood movie, so there are a lot of new generation robots who are like connected and they try to attack the human beings because
who is going to control those robots?
The operating system that gets corrupted and it tries to attack human beings to take control over the world, something like that.
There will be master robot, is there?
The master robot in iRobot is actually the operating system at their headquarters.
Yes,
but
yes,
for
very good, sir. Very good.
By Rajinikanth, the master robot is one robot itself.
Yeah, yeah, very good, sir. Very good, sir. I think thanks, thank you. Actually, it's just very good. Thank you, sir. Yeah. Now see here, it's a distributed denial of service. See the master, the control, because I'm going to attack the master. And the master attacker will identify the master robo, and master robo will follow because all the slave will follow the master robo. If I get a control of the master robo, and then where I can get the control of all the robos. So therefore, that's the concept of Mirai botnet attack will comes into the picture. It is a distributed denial of service attack which is going to happen. Now this is more devastating, especially in IoT devices, because if I get a master, if I get a network, IoT network, if I know the control of one network, then I can control all the sensors which are connected to that network. That can be happened, especially in IoT. So Mirai botnet attack is going to happen on all the layers, which is going to happen on TCP, UDP, right, with GRE, general routing encapsulation, or application protocol. The attacks can be. If these are the attacks, so therefore attacker will have a control server, and then from that control server is going to attach the botnet nodes, and then he is going to target the mission, target the traffic on a particular system, right, which is going to happen. Now, if you see here, which is just now I explained, the botnet master will have a command and control, and then he will send over into cloud to all the nodes, and then he'll attack a victim, or he will scan the new nodes where the malware loader will come into the picture for reporting the server, which is going to happen. So this is called as a distributed denial of service attack, or Mirai botnet attack, which we call them Mirai botnet attack. Right, the attacks can be happen on Raspberry Pi bots, which is a work which is done by a group of people, which we can say, right, this is an attack which is going to happen, and this is a protocol which is going to use, and this is a packet size which is going to be used, and this is bits per second and packets per second, which is going to happen on the attacks. Okay. So therefore, it's a distributed denial of service attack. If you see Mirai botnet attack, which has happened on Krebs on security, and almost it's a security company, and the Mirai botnet attack has happened on that. This is a Mirai. If you click on this one, you'll come to know how the attack is happened on this area. So therefore, now we need to provide a cyber security, that machine learning security, or cyber security mechanisms, definitely with respect to that. Right? We'll try to see quickly how we can apply this problem. Now, our main motto is to provide the associated data as well as the information here, how to protect the information, how to protect the data. Right now, if you see, there is a commonality will be there in ML and IoT. Can you know what is the commonality in IoT and ML or AI? Anyone can give the answer? There are commonality will be there, common word will be there between the IoT and ML. Anyone? So now, what ML requires? What ML algorithms requires? Data, right? Very good. So ML algorithms requires data, and IoT is going to generate the data, right? Right. The commonality word which we both the things are the data. Data is the value, isn't it? So now these data need to be there. This data can be sensitive data. This data need to be process it, analyze it. That a lot of operations need to be performed on those data to get the appropriate information, or to make that information into intelligence. Okay, which we're going to have. Right now, we need to keep the bad guide out. That's one thing. How we can keep the bad guide out? How can I come to know that who is listening this class, and how can I come to know that who is not listening the class? So it's very difficult to identify, because it is very difficult to identify the passive learners. But active learners, I can easily identify, okay, these people are listening and these people are not listening. So it's we need to have some intrusion detection mechanisms. So what I'm going to do is, every 5 minutes or every 10 minutes, I'm going to keep a quiz. So whoever give the answer, whoever writing the answers, and then they are going to, I can say they are the active learners. Passive learners means just they will keep on and they will go somewhere. 1 hour, 2 hours, no. So I can see, because even. Okay. See, that's a point, because few people will keep on somewhere and they're going to do some other work without concentrating. So we call them as a passive learners there. So keeping the bad days out. Now, if you want to conduct FDPs with effective, now everyone is interested only, we need to allow. So what is that? We need to keep bad guys. Means attackers will exploit the whole environment. So protecting your internal network need to be there. Recovering from the attack should be there. Means we need to apply somewhere some learning algorithms here for recovering the data from this and from protecting from the internal network. Right. So for that, what we are going to do, we need to have some assessment need to be there. Okay. We are going to use it. Suppose, for example, we need to identify. We need to protect it. We need to apply certain, and we need to detect it. Now, this is where your machine learning algorithms can be used. Develop and implement an appropriate activities to identify the occurrences of the cybersecurity event. If something abnormality is happening, immediately your algorithm should tell, yes, something is going on. Yeah, immediately it should be elected. Like suppose, for example, already Google using some inactivity, something is happening, immediately it will send you something is going on, whether you're the right person or not, because everything it will be detected and they'll give the information to you. So some machine learning algorithms already adapted by the Google, some machine learning algorithms already adapted by the Microsoft. If something goes wrong, immediately unauthorized activity, something is happening, it should identify it, and early protection should be done using some machine learning algorithms. Right. So we can say that the success of IoT mainly depends upon the trust, identity, privacy, protection, safety, and security. First, the trust need to be there. Trust need to be built in. Then identity need to be ensured. Right. We are dealing with millions of devices. Privacy is a major concern. Protection is a major concern. Safety is another concern. Then security is the other. The success of IoT is purely depends upon 6 important. Now we'll try to see. I think if it is already covered, I'll skip it this one. But we can use ML in IoT, that we are going to see. I think you already know that, though it is derived from AI, and which is we are shifting towards the algorithms because we are training the algorithm. We are giving the algorithm to take the appropriate decision making, and that are completely available as well as the robust. That's it, right? No, I think you already know that we are going to use a lot of stuff, especially machine learning algorithms are there. I think from last 3 to 4 days, you come across all these things. Now, where we can use in bioinformatics, we can use in speech recognition, spam, the spam detection, which is a spam message. Automatically, you can see in certain spam detection can be happened here. Computer vision can be there. Fraud detection in security, fraud detection can be happened. Advertising networks, in routing networks, Benson message. Whenever the user is entering into the proximity, it should be detected and the Benson messages need to be sent. Okay. So we need to apply the machine learning algorithms not only in certain areas, but also in all the areas of IoT can be used, right? Which we're going to use. Now, the role of the machine learning in IoT, where we can use it in the sense we can say ML is the main method that can be applied in any computational applications to the IoT. A lot of applications can be used. As I already told you in the beginning, in my previous sessions, in my previous sessions, we can use in edge computing level, we can use at the edge devices level, we can use in networking level, we can use in cloud level, we can use in big data analysis application level. So a lot of applications we can use for appropriate decision making can be done. You see, for example, the ML algorithms can be used in research area to flood the IoT data. See, that's why we can how to evaluate the data, whether it is a suitable data or whether it is redundant data. Now we need to have a transmitting anonymous data patterns, right? We require from various devices, type of devices. Now, how can we convert that big data into smart data? Means we need to apply compulsory ML algorithms or applications to convert from a big data to a smart data. That big data can be converted into a big data into a smart data. The first very important thing, right? That's data processing architecture. We can use ML, and we can use in routing, as already told you. In wireless sensor network, we can use ML algorithms. And routing mechanisms is another area where we can use ML algorithms. We can use in energy savings, because as I already told you, power consumption and energy is a better way. And which are suppose there are cases where the nodes are getting the nodes are not generating the data. They want to enter into sleeping mode. So by saying that to save the energy, ML algorithm should work at the devices level, and immediately we require lightweighted algorithms here. We cannot use heavy loaded resource hungry algorithms, because we need to have lightweighted machine learning algorithms need to be there, right, to make it to save the energies, especially in this in the energy of a wireless sensor network. And as I already told you, we can apply very effectively in machine learning algorithms in intrusion detection systems. I think a lot of data mining stuff is used here, but now we are using machine learning algorithms like network traffic is generated. We are going to take some future generation is going to happen. And then we are going to use some classification phase like machine learning algorithm 1, 2, 3, and so on. And then we are going to give some proper alerts as well as the warning. Warning can be done using a hybrid-based intrusion detection system. Okay. And these are some of the applications where we can use this ML as well as the analytics. One is utility in utilities like gas, water, and these things. We can use analytics as well as machine learning algorithms can be used. We can use machine learning algorithms in manufacturing sector. So if something goes wrong, which you can use it, right? Other applications. We can use it in the healthcare sector. That's very, very, very important, because the healthcare sector is very important. Because IoT devices, when we talk about IoT with machine learning, you can see whenever the data which is available, like electronic health records are there. Now, whatever the data which is coming from the various sensors, we are going to store in the form of EHR, electronic health records or personal health records. Now, those health records need to be processed. We are going to store it at the cloud. We need to process that data. Now, those data, we need to apply some deep learning mechanisms, some machine learning mechanisms. Suppose, for example, we need to identify the diabetes patients. Like pre-diabetes patients need to be there. Now, up to now, he is not having diabetes, but once we get the live data, we need to be processed, and machine learning algorithms should be alerted that you'll be more vulnerable if you take more these things, and the diabetes is expected to come. So, this type of analysis need to be done in the healthcare sector, And insurance sectors, we can use anomaly detections can be happen using some machine learning algorithms. Okay. And we can use even deep learning intelligence, because is another way where to get accuracy levels, more accurate levels in healthcare, retail, and mobile and automobile and smart city. Deep intelligence is required, where we can use the neural network stuff and all these things from edge devices, middle network, as well as from the cloud. From where this is one neural network, this is another neural network. These are now we need to integrate it in the at the cloud intervals, and then we will get the devices. Okay. Thank you. I think if you have any doubts, that's it. I think I covered the role of IoT. If you have any doubts, please let me know, sir. If you have any doubts?
Hello. Yes, any doubt from the audience? Hello.
Yeah, Osman, I think what is that? I'm a research scholar working in providing security for DNS. Yes, you can use service discovery mechanisms on DNS. You can use it. Service discovery on, because we will try to use multicast DNS, isn't it? Multicast domain name services. You can apply a distributed denial of service on DNS. Security can be provided on multicast. Unfortunately, multicast concept is applicable on IoT, but it is not there in traditional internet. You can go for some multicast mechanisms on DNS to eradicate distributed denial of service. No, if I give a ML algorithm here, definitely that solution will not come into the picture. But you can apply like a linear regression algorithm is there, which is good enough to identify the patterns, especially the different types of patterns, because you are applying on application level. We can use a deep learning mechanism, or you can use different. No, only one thing is no one algorithm is better. You need to apply the hybrid mechanism. We need to apply somewhere linear regression, somewhere decision tree, somewhere SVM, and you need to compare which one is giving the better results on that. You need to apply somewhere even the signature based also.
Yes, any doubt or any query to our speaker? Sir, I have the one doubt. Can you tell me what kind of event and how the fog computing can be implemented in the what kind of application?
Sir, can you repeat? I think I am not audible your question.
Sir, how and what way the fog computing can be implemented in the what kind of the application?
See, for example, now you can use for all the applications cloud computing or fog computing. Suppose, for example, you're placing in health sector. Now you are having a body area network. All the sensors were connected to your body, and all the devices were connected, and the cloud somewhere at the different places. Now, what is that? Whenever we are going to create your mobile node can act as a fog node, where the sensors data will be sent, that information to your fog node can be processed, and then that data can be sent to the cloud node or to the doctor for happening. So the fog is nothing but it's like a distributed cloud, sir. The fog computing, fog cloud, we call them as it's a distributed cloud which is very close to the devices, which are very close to the devices, where the cloud is very far from the these devices. So definitely we need to apply the fog computing for efficient first level of processing can be done using fog level. Second level of processing can be done at the cloud level. Now cloud will get quality data where already already filtering, evaluating can be done at the first level. So therefore, we'll get the fine-grained data or well-defined data into the cloud. So processing, even for big data processing, it will be easier.
Okay,
Hello,
sir.
sir.
Thank you, sir. Yes.
Hello, sir.
Yes, sir. Please, sir.
I am new into this IoT because I have not worked too much on IoT. But now we are talking about huge amount of data being handled by IoT and so on. Are these boards, the boards used for IoT, powerful enough to handle so much amount of data?
Come once again. Please come once again. I'm not getting your question.
Like we are talking about huge amount of data being handled by these IoT devices and the IoT infrastructure or the system. Are these boards that that are being used for IoTs powerful enough to handle such amount of data? Like the data
No,
coming
you
from
cannot
the
handle it. So
database?
you take Arduino board, you take a Raspberry Pi board. They are only we sense the data and they'll do the data and the data we call the real time data. But we need to store. No, they cannot process there. We need to apply
Yes.
again machine learning algorithms there at the board level itself.
Okay.
At the board level itself, you need to apply machine learning algorithm. You need to deploy the algorithm there to take efficient decision. That is very challenging.
Okay. All right.
Gautam sir, can you ask? I think it's clear your doubt.
Yes, sir. Yes, sir. Yes.
Done, sir. Yes, clear.
Any other question from the audience? Okay, I think there is no doubt right now, sir. And the audience will make a query to you in the personal your email ID. On behalf of the GTU and the British School of Engineering and Technology, and the Center of Continuing Education of Warangal, I am very thankful to the Professor P. Suresh Babu for sparing his time and his knowledge to our participation of the FDP. And so, sir, you covered the very important aspect and the most of the topic related to the cloud computing, architecture, network model, protocol model, and IWS reference model for the IoT. And also you have discussed the cyber attacks, and also you have to given the idea about the machine learning, how can be useful in the IoT. It is very informative session, and one of the wonderful sessions that we have seen from the your side, sir. So this is a very good session from the for the FDP, and I am very thankful, and we will be invited for the other kind of the intervention from our side in the future. Thank you very much.
Thank you very much, sir. Thank you very much, sir. Thank you for giving me opportunity to share the knowledge to all the participants, and I thank especially you as a coordinator for inviting me. I'm very thankful to you, sir, Gautam, sir. Thank you very much.
Okay, thank you very much.
Thank you, sir.
Now,
May I leave?
dear, yes, sir, you may leave now, sir. Thank you
Yes,
very
yes.
much.
Thanks.
Yes, everyone, there is a 10-minute break, and we will start our last session by the Dr. Raju Bhutia. So there is a 5-minute, 10-minute break, and we will start our next session. Professor Raju, sir, am I audible, sir? Hello, Professor Raju, sir. Professor Raju, sir.
Yes, sir. Yes, sir.
Shall we start, sir? Okay, this is good morning to everyone. This is the last session of our FDP ISC Project 2 sponsored online faculty development program on Internet of Things with the machine learning and artificial intelligence. This is our last session, and I, as a coordinator, Dr. Gautam D. Upana, warmly welcome our resource person, Professor Rajiv Bhukia from the NIT Warangal. The topic of the today's session is blockchain in agriculture. Professor, it is my pleasure to welcome and introduce our speaker, Professor Rajiv Bhukia. He is assistant professor in Department of Computer Science and Engineering at the NIT Warangal. His research area are software engineering, bioinformatics, IoT, machine learning, and blockchain. Dr. Raju published more than 30 research papers in reputed international journal and conferences. He is involved in the various kind of the IoT solution in the with the help of the machine learning and the blockchain, and he received the best social care award at the SCRESM conference at Belgavi, Karnataka. With this, I hand over this session to the Professor Raju Bhutia for his wonderful knowledge sharing to us. Over to the Professor Bhutia, sir.
Is my screen visible, sir?
Sir, yes, sir.
Okay, sir. So blockchain in agriculture. Okay. So status of Indian farmers. The farmers regarded as the heart and soul of the Indian economy. We are struggling all over the world to tell that produce. They want to sell their whatever the product they produce. They want to sell at the decent price, but they are unable to sell that particular whatever the product they want to produce. Okay, so they will work day and night and they will cultivate the crops, but they are unable to sell this particular particular product at different markets, and different markets will be having different prices, and that was the problem. They are unable to sell the particular product at a very good price, and most of them often they sleep with empty stomachs. They will work hard, but they will sleep with the empty hearts daily. Okay, so that was the one of the main reasons, and other reasons are reasons for farmers financial distress is unfavorable climatic conditions. See, when rainfall occurs is not known, or every year by year, if you can see year by year, every year 2 centigrade of temperature is increasing. As the temperature is going on increasing and increasing, the rainfall or the whatever the water available within their bores or within their wells is going deeper and deeper. With that particular thing, we are unable to get the water, and due to that we are not able to produce the production at a good particular thing. Okay, so that was the one sort of thing, like unable or unfavorable climatic conditions, whatever may be. See, we are not known when the rainfall occurs. We are not known when these particular other particular climatic conditions are. That means we are not at all known the climatic conditions day-to-day analysis, or inadequate and poorly distributed rainfall. This rainfall, whatever it occurs, it is totally and poorly distributed. It is not an inadequate, or lack of availability of the irrigation water. So if you can see the greenhouse farming when compared with the conventional, suppose greenhouse farming, you don't need the high water usage, because each and every plant you are having the sprinklers, like with a very less amount of water you can, that means there will not be any wastage of water. There will not be any wastage of water with the help of this particular greenhouse. That means when compared with the conventional farming system, greenhouse farming is much more better. Okay, because of lack of availability of the water, because of, see, the land, see, going on, that means a family will be having some 5 to 6 people. Within this 5 to 6 people, like the total land, whatever the land which is having, it has been totally having given to that particular family members. That means suppose I'm having 5 acres and there are 5 people. This 5 acres has been distributed to 5 people. Okay, and further again each and every family will be getting 1 acre. Again it will be distributed into their children and so on. Like, so that is the thing. Sometimes lack of availability of land, that means land is scattered into small pieces, and there is no availability of the water resources, or irrigation related water resources not properly distributed, and so on, or frequent crop failure. See, if we can go to the market, then we are not known, or the farmer is not aware of related which company of seed is very good, or which company of seed is not good, or which company seed is bad, or which company seed is giving the highest product, or which company is having a high priority. Like, he is not aware, so he will go to this particular shop, and what he will do is he will just ask the seeds to give some company, and that particular shop holder, he will give you that particular some sort of seed, and accordingly he will have, and whether he get good production or not, we are not aware. So that is the thing. That means here farmer is not aware of related seeds or related pesticides or related insecticides, or he is not aware of the technology. He is not aware of the technology. So he will not be using the technology, and he will go to the shop and he tries to explain something, and accordingly the shopkeeper will give some sort of thing, and he will take that particular one and he try to sow it, but ultimately he will not be getting any sort of production. So that is the problem. That means frequent crop failures. Okay, maybe that may be the one problem. Division of land holding. So that is the thing. As we have discussed, like a particular family is having some 5 acres, and there are 5 children, and this particular 5 acres has been distributed into these particular 5 children, and again this particular each and every family, again further they will be having 2 children, and again they will be getting half acre. That means within the small land holdings we cannot get good production. So that is the thing. We can go towards the greenhouse farming, where we can use the IOT devices, and where we can use this particular blockchain related technology, and we can get a very good production with the help of less water usage, and with the help of technology, whatever the latest and current technology we are having. With that particular current technology, we can have more and more production with the help of less usage of water, less usage of the pesticide, and less usage of the manpower, and less usage of the insecticide, and whatever the things we have, we can use very less, and each and everything we can operate with our mobile. So this particular thing has been available with the app, and you can each and everything you can operate with your mobile. That means each and everything you can monitor with the mobile. That means, see, you are having a particular algorithm which has been designed with the particular artificial intelligence or machine learning algorithm. Then your system will recommend you that whenever a particular plant, say a particular plant, suppose paddy needs so and so particular amount of water, or suppose like cotton needs a particular amount of water, or suppose chilies needs a particular amount of water. When these particular plants or these particular crops are having less than the threshold amount of water, then your system will automatically detect it, and it will give you the warning that your motor pump should be on, or your, so the whenever, or suppose another particular machine, like, or suppose another like sensor which detects the humidity, or which detects the water level, or which detects the some other thing, and it will directly give the information to your centralized system or to your application, and accordingly you can react it. That means you don't need more and more number of human resources to have all these things. Okay, so less area means less income. Suppose in conventional way, if it is less area means you will be getting less income, but when if you can move towards this particular greenhouse farming, less area you can get the more income, because it is a vertical farming, like. So that means you will be getting more and more income within a less amount of land. So most farmers to sell their produce at decent price, but they are not able to. That means they are not known. They are not known where to sell and how to sell, and they are not aware, and they are not known. Exactly, they are not known. So always middleman enjoys the profit. Middleman will be enjoying the profit. See, neither the buyer nor the seller, neither the buyer is enjoying the profit nor the seller is enjoying the profit, but always middleman will be enjoying the profit, and always farmer will get the loss. So because of lack of the transparency in supply chain. So blockchain, so coming to the how blockchain works in supply chain. The blockchain is based on the shared ledger. So these blockchains are each and every blockchain will be having the records, and these particular transactions will be details and its information which are called blocks. These particular blocks will be having the information, and these blocks are immutable and they are tamper proof. So you cannot change it, you cannot change as you need. Once you have had updated or something you have inserted within these particular blocks, you cannot immute, or you cannot write, or you cannot update it like that. Means there only this one can update, but each and every one cannot update it. The data in this block are hard to alter or hack. So it is very important that you cannot hack this particular data which is available in blocks, or you cannot alter. Alteration is not at all possible, or it is not able to hack this particular data, whatever the data which is available in the blockchain. These blocks holds incorruptible trust. So you have to always you need to trust this particular data, whatever which is available within this particular block. Anyone can put the things of value on blockchain, from gold or tomatoes or anything, whatever the things, each and everything you can put it within this particular blockchain. Whatever the thing, like you can have related any sort of thing, you can put it in this particular blockchain. So farmers, consumers, retailers to share information. See, like suppose I can give you an example, like suppose whenever in my field I'm having the IOT related devices. Suppose greenhouse farming, suppose I'll be having the water related sensor, I'll be having the humidity related sensor, I'll be having the color related sensor. Okay, I'll be having some other or some color or some different sensors, soil related, soil health. Okay, like I'm having number of sensors. I'm having the number of sensors. With this particular sensor, I can get the information. So suppose if the plant leaf it is going to that is changing, then your color related sensor will detect it and it will give the information to you. Or suppose water related sensor, when the water level is less than that the threshold level, then it will track it, and accordingly it will give the signal that water level is less. Or the suppose some other soil health, suppose soil health is not up to some extent, or it is not up to the threshold, then it will give the information to you. Or suppose at a particular amount of time you need to have the pesticide or insecticide, then it will give the information to you. That means at each and every time you are having, your system will be having that at a particular amount of time what sort of insecticide or what sort of pesticide you need to use, or at what sort of water content you should have for a particular plant, or how the humidity should be, or what should be the outside temperature, what should be the inside temperature, or what should be the cooling related, or what should be the heating related, or all this sort of information will be available with your application. Once that particular application, within that particular application, if your system detects, if your algorithm detects the system is less than the available parameter, then it will detect it and it will give the information to you that so and so is less than or it is more than. Suppose your plant should have the cooling related at so and so level, but it is moving higher than that particular one, then it will detect it and it will inform you that now it is moving more than the current particular needed temperature, then you have to, or your system will down that particular temperature. So that is the thing. In this particular way, we can have we can use this particular IoT and blockchain, and we can overcome the things. Okay, so maximum safety and transparency and speed. Once the data is validated, it gets recorded into the blocks. So you need to validate the data before you need to have that particular data into blocks. You need to validate. Once it has been validated, it gets recorded into the block. So information about the every cycle, entire cycle of the agriculture events onto the blockchain. So from starting, see, like suppose we can have an example. Like, see, whenever I sow the seeds, whenever I sow the seeds, what company, who has from where, which shop or which company, from which shop, on which day you have brought this particular a seed, it will be sent to the blockchain. It will be sent to the blockchain. And then after 5 days, you should have some pesticide. Then which pesticide you are using, that particular information is sent to the blockchain, into the blocks. Okay, and after some time you are irrigating the water, or you had some pesticide or insecticide, or again your color is going to be in a yellowish color, and now again you are going to have some pesticide or insecticide. Again that particular information will be sent to this particular block. That means starting from the sowing to the production and to the food industry or food processing companies, and to the final customer, until it reaches the final customer, each and everything, each and every stage will be recorded into the blocks. It is recorded into the block. Suppose tomorrow something happens. Suppose the shopkeeper may tell that this is a very good company and you are going to get a very good production, and it is a high rate related seed, and he can misguide you and miscommunicate you, and he can give you another local company or a very which is a very bad related seed company he can give you, where you will not be getting very good production. That means here now the details has been, each and everything has been sent to the blocks, and who is the ultimate victim will be given by that particular blockchain. That means from starting to the sowing to the until that particular product goes to the consumer, until that particular product goes to the consumer, each and every stage, each and every time, each and everything will be recorded into the blocks. That means you can easily track who has done this, what was the problem, how this problem has been occurred, who was the ultimate victim for this particular problem. You can easily track. Suppose if you are not getting the production because of this particular seed, we are not getting the production. Suppose you had irrigated very good related water, or pesticide you have used, or insecticide, or each and everything you have done in a very good manner, but also you are not able to get the correct production. Then it is not your mistake, it is some company's mistake. So that is the thing. That is, you can easily, there is a transparency, you can easily you can track who is the particular one for this particular risk. Okay, so enable transparent and trusted source of information for the farmers. Like, it is a trusted source, trusted information and source for each and every farmer. See, from I have brought a particular seed, the seed is so and so company, some X company. I have brought it from so and so shop. Okay, and after that I have sowed it, and I had I am doing my related things, and slowly it is not giving related production, or it is not giving related things. That means each and every day the total production of that particular seed is 120 days, but it is taking 150 days. Although it is taking 150 days, we are not able to get related correct production for that particular seed or for that particular plant. Then it may be a problem with that particular company, seed company. Maybe farmer get data related to seed, related to soil, related to climate, related to environment, related to payment and demand and sale price, and each and everything. This is a cycle from starting from the sowing, starting from the soil. What sort of soil is very much useful? What sort of soil is recommended for this particular plant? Suppose chilies. What sort of green, or what sort of soil? Maybe black soil, or maybe red soil, or maybe some other soil. Which soil is more recommended, or more which is near, or what is the nutrient content of that particular soil? Is the nutrient content of, that means your nutrient sensors will be detecting what is the nutrient content within that particular soil. Is nutrient content is okay for this particular plant, this particular chilies, or this particular crop or not? You need to first detect it. Accordingly, you need to have it. Like, okay, so that is the thing. Farmers get detailed data about the seed, or about the soil, about the climate, about the environment, and about the payment details. Suppose if this particular there is a huge drought, there is a huge like a rainfall within this particular within a particular month. Suppose within a September month there is a huge rainfall within a particular area, maybe some Hyderabad. There is a continuous 10 days of rainfall in Hyderabad area. Then what I'll do is I try to get some crop insurance. I'll apply for the crop insurance. Now crop insurance officials or insurance company don't want to like they want to traverse and they don't want to go to that particular field for giving this particular insurance or not. That means, see, they can get the information. They can get, because here each and every information is available. Each and every information is available in your blocks and in your IoT. If you can take the IoT related system within that particular field, within September 15 to 25th, is the 10 days rainfall has been occurred within this particular area or not. He can check that particular record. If it is recorded, then he will not check or he will not inquire and he will not do any sort of survey there, and directly he will transfer the money into the particular farmer's account. So that is the beauty we are having with the help of this particular blockchain technology, with the help of the IoT. So get the data related to seed. What sort of seed? If this seed is related to this particular soil or not? So what sort of climatic conditions? What sort of environment? Okay, and payments, demands, and sale prices at different areas. Maybe sales price of Hyderabad, maybe sale price of maybe Nagpur, or sale price of Delhi, or sale price of particular maybe Mumbai. The like chilies price at different areas, different locations. See, now the farmer may sell his like a product at anywhere. So what was the price? Why the price is different at different areas? So he has to know that particular information. So why is blockchain technology? Okay, so it is a secure to store. It is a secure to store. Once we have stored, we cannot alter, or we cannot it is not possible to change, or it is not possible to do any sort of things, or we cannot have that particular one. Anything you can do, like currency, stocks, contracts, and vote, any sort of things you can have it like. Okay, so blockchain in agriculture, like IoT devices were generating the data. Suppose if you see the greenhouse farming, if you can see greenhouse farming, suppose I am having a particular system. My system has been integrated with this particular greenhouse farming. Then each and every sensor, I'm having climate, that is temperature sensor, I'm having water sensor, I'm having cooling sensor, I'm having heating sensor, I'm having nutrient related sensor. Okay, I'm having related water content sensor, like, and color related sensor. Like this, I'm having number of sensors. All these sensors which has been accommodated in this particular greenhouse. All these sensors has been accommodated in greenhouse, where greenhouse each and every sensor will be giving the data, will be sending the data to this particular centralized system. That means IoT devices, all these sensor devices are generating huge data. Suppose based upon your algorithm, it can generate data for every 1 second. This particular second, what was the water content? Next second, what was the water content? Okay, some 2 centimeters or 3 centimeters water available within this particular paddy, or some some cotton or some chilies. This is the particular threshold, but available is this. That means your water related sensor will be going on sending the data every 1 second or every 10 seconds and so on. That means you are getting a huge data. In the same way, nutrient content particular sensor, it will be going on sending related the nutrient of that particular soil and of that particular plant. Or plant growth related sensor, it will be sending related the plant health, plant related information. Or like each and every particular device, will be going on sending the particular data from the source to destination. So that is the thing. IoT devices are generating huge data, huge data. So we need good processing, we need good algorithms, okay, good techniques to process all these particular data. Okay, so population across globe to touch 9.6 billion by 20 50. Okay, so to feed these particular increasing population, it is very difficult. It is very difficult. So we need to adopt new technology, new techniques, okay, new parameters, because due to current conventional agriculture farming, we are not aware when rainfall occurs, or when some other things, or when drought, or when this one occurs. See, we are not at all aware of these things, but with the help of this particular greenhouse farming, each and everything is controlled. Your rainfall doesn't enter into this particular greenhouse, okay, and your suppose heating will not, you can adjust everything. Whenever you need the cooling related to that particular plant, you can cool. Whenever you need the heating, you can heat it. Whenever you need the water content, what sort of water content, you can have that particular water. That means each and everything has been controlled. Each and everything has been controlled. You can control everything. So IoT enabled smart farming is built using different sensors, maybe temperature related, pH related, soil moisture, humidity, or light related. These are the various sensors you can have. Whenever you need light, you can on your system, your application can on it, or whenever you need humidity, or whenever moisture, what sort of moisture you are having, or what sort of soil moisture, or what sort of temperature you need, okay, accordingly you can generate it. Okay, so technological transformation, okay, so satisfy the demands of growing population. So day by day, year by year, the population is going on increasing and increasing, so you need the good food. See, today we are not known, we are not aware of what sort of pesticides they are using, whether those particular pesticides are recommended or not. See, farmer is not aware of like whether this particular pesticide or insecticide is really needed or not. Suppose he will go to the shop, he will go to the shopkeeper, and the shopkeeper, he will explain something, or he will show the leaf, or he will show some plant, and this is the problem, try to give some insecticide or pesticide to get good condition of my plant. Then the shopkeeper will give some sort of pesticide or insecticide to him, and he will use that particular one. But what is the guarantee that particular pesticide is used, or that particular pesticide is good? We are not aware. Again, if there is no change within that particular pesticide or within that particular plant, again he will rush to the shopkeeper. So whatever the thing which you have given has not worked, again he will ask to give an alternative or another one. Now again the shopkeeper will give the another one. Again that particular thing is we are not aware. Again that particular thing, how much it will be working or not. So that means this sort of things. That means, and see, it has not worked, but he has used 2 to 3, or he'll be using number of pesticides which we are consuming daily, which is very much harmful to our body. It is very harmful. So that is the thing. So with the help of the greenhouse farming, with the help of these particular IoT sensors, and with the help of this particular blockchain technology, the system will guide you. The system is already inbuilt. When if this particular problem occurs, then you have to use these particular insecticides or pesticides at particular stage. At day 1 you have to do so and so. At day 2 you have to use so and so. In day 3 you have to use so and so. Suppose we are having a particular application app called Plantix. A particular application called the Plantix, where suppose if you have if you are like sowing the seed, and if you can register within this particular Plantix application, then they will guide you. Day 1 what you have to do, day 2 what you have to do, day 3 what you have to do. Maybe your plant may be going into this particular stage, then you have to have this so and so like. That means each and every information they will be giving with the help of these particular SMSs and so on like. So that means day to day, or within once in a weekly, they'll be giving related weekly basis what sort of updates you have to do, what sort of pesticides, or what sort of insecticide, or what sort of other updates you need to complete, or we need to do. All these things will be given by this particular Plantix application in the same way. That means with that you don't need to. So whatever the, suppose at the 10th day you need to use a particular insecticide. Then you can ask, or you can take a photo of your plant and you can give it to you can upload it to that particular application. Within a half an hour, you will get the total and entire details. Okay, so that is the thing. So advanced technological solutions to meet the changing consumer needs. So the consumer needs are going on changing and changing. So that is the thing. Day by day, we are consuming lots and lots of pesticides and insecticides. So that is very much a danger, which is causing a lot of diseases and cancer, and that is the thing. So we need to take agriculture sector into with the help of this particular technology based, and whenever we need a particular thing to be done, a particular work to be done, then only we have to do. That means, see, the same farmer, if he is able to use this particular technology, if he is able to use the particular application, then he doesn't need to rush to the shopkeeper like to give so and so. So he will be given these particular pesticide has to be used by you. Then he will just show the photo or just tell that particular pesticide or insecticide accordingly he can use, so that his plant will be in good condition. That means unnecessarily we don't need to consume different pesticides and insecticides. So that is the thing. Okay, so encourage sustainable agriculture practices, decreases agriculture supply chain cost. Like, okay, everything you will be getting the profits, each and everything you will be getting profits. Increase the income of small and medium farmers. See, with the help of this particular like greenhouse, you will be each and everyone. So vertical farming. So vertical farming, like whatever, suppose you are having 1 acre or half acre or whatever you have, you can get a very good income, because each and everything has been available with the help of this particular blockchain and this particular IOT systems. IoT sensors and devices will be generating a lot of data. They will be generating the data, and it helps the farmer to make decision for the crop growth. So these particular IoT sensors, suppose crop growth related sensors, it will be giving you the data. Suppose water related, it will be giving you the data. Moisture related, it will be giving you the data. pH related, it will be giving you the data. Heating related sensors, it will give the data. Cooling related sensors, like there are n number of sensors will be equipped with your greenhouse farming. Each and every second they will analyze and they will sense it, and they will give the related data to you. So that is the thing. Okay, helps farmer to make the smart decisions with the help of this particular greenhouse farming. Okay, so water level, you can have water level, temperature, humidity, nutrients, and so on. Like, so information gathered from IoT devices need to be structured. Okay, whatever the information we are getting from different IoT devices, they need to be structured. Okay, once they have structured, then we can do any sort of things. Okay, making the data useful with machine learning algorithms. So whatever the data which is available, you need to use this particular data, and accordingly with the help of different algorithms, maybe machine learning algorithms or AI algorithms, you can have you can process the data, and accordingly you need to take some related decision making. Okay, so machine learning is applied on data generated. So huge data is generated with various devices. Accordingly, you need to take this particular data, and you have to take some sort of decision making. Okay, your algorithms will they will process it, and accordingly they will run, and accordingly they will suggest you. So these particular decision you have to use, like maybe some predictive models or some other things, some sort of parameters you need to use it, and accordingly you can, these particular algorithms can product related to crop quality, maybe crop identification or yield production. Maybe, see, whenever you are whenever suppose you want to do some sort of this one, then with the help of some tractor, suppose you want to sow the seed with the help of some tractor, suppose, then your tractor will go through the entire land. then your tractor will be getting the coordinates. Okay, it will be getting the total coordinates of your total land, and it will get the entire land related area. Accordingly, it can identify and it can predict. Your system can predict it. Your system can predict that this is the your crop production will be so and so. Like it can give you the prediction, like, okay, growth score, it can give you the growth score, or automated crop growth factor. So like, or prediction, or like demand prediction of this particular crop. Suppose every year, if you can see, every year onions prices will be changing. That means will be high in the month of October, November, or September, October, and November. Every year, if you can see, that means whatever the crop you are having, what was the growth or what was the demand once this crop comes into the market, what was the demand for this particular crop, you can have it. Like information captured through different machine learning algorithms. Farmer can improve irrigation systems, like, so whenever, so in whichever the way he needs, whenever he needs the irrigation system to be used, then only he will use. But when compared with the normal or the conventional, he doesn't know when to use and how to use. Daily he will be using these particular irrigation systems. So that is the thing, that is the difference between the normal and the conventional, that is the greenhouse related farming systems. Crop and food production. See here, IoT sensor could fetch information, like it will be fetching the information related temperature, related water level, or fertilizer details, or each and everything. It will sense it, and based upon the data saved in a blockchain, smart contracts could trigger the specific action. So here you will be saving each and every related parameter related to water content, or related to the fertilizer, or related to temperature, or related to the cooling related or heating related sensor, or a plant growth related sensor. Each and every related sensor has been sent to this particular like blockchain. Based upon that, you can make related decisions. Okay, based upon the data saved in blockchain, smart contracts could trigger it. It helps in enhancing the quality of the farming. Okay, so that with the help of this particular one, we can enhance the particular farming, this one. Okay, so food supply chain tracking is critical in exploring the source of food originated to that one. Suppose now we will take a use case. You will take a use case related to the agriculture system, like from the starting, from the sowing of the seed to the until it goes to the consumer, and consumer consumes it. Each and every stage, we will have the information. We'll be having the information. Each and every information is sent to this particular blockchain. Each and every information is sent to the blockchain. Suppose food supply chain tracking is critical in exploring the sources of the food originated. Suppose I can say that suppose I can say apple, this particular apple is originated, or this particular apple is grown from Kashmir, but that particular apple is from Hyderabad, or that particular apple is from the Delhi. We are not known. See, but with the help of this particular blockchain, we can easily understand. With the help of this particular blockchain and IoT, we can easily understand. See, whenever you have sown the seeds, or whenever you have taking the temperature, then you will have the coordinates of that particular field or that particular land related things. That means you cannot bluff that this particular product is from Kashmir, or this particular product is from Kanyakumari. So that means each and everything is available in your blockchain. It is available in your block with the help of this particular IoT devices, because your IoT devices, each and every second, they are sensing the data, and they are sending to this particular centralized system. So that is the thing. Each and everything is transparency, from starting, from the sowing, from the cultivation, from the sowing, cultivation, sowing, and fertilizer, and pesticide, and water content, or rainfall, or flood related, okay, or the production to the go down or warehouses, from that each and every stage, it will be recorded into this particular, it will be recorded into your IoT system. Okay, ensure that supply eatables are safe to you. See, that is the thing. See how safe we are eating. Today we are eating different vegetables. We are not known from where those particular vegetables has grown. We are not just, we will buy there and we'll just eat it. But we are not at all known in which climatic conditions, how much pesticide has been used, how much insecticide has been used, under what climatic conditions this has been grown. And what sort of water it has been. See, some news we will be getting sometimes, like some vegetables will be grown in wastewater. Whatever the water we are sending, wastewater, it will be grown. That means that, but with the help of that particular water, if the vegetables or with some sort of plants are grown, then what is the health of the people? So all these things we have to understand. But with the help of the particular blockchain technology, we can overcome all these things. We can overcome each and everything. We can that means each and everything has been stored into this particular system, and you cannot bluff, or you cannot say because each and everything is a transparency. Each and everything transparent. What sort of fertilizer you have used, what sort of pesticide you have used, everything is available in your blockchain. In blockchain, it's possible to bring transparency. Okay, it is very much possible to bring the transparency. Okay, food supply chain ensuring food safety. Okay, so ultimate goal is food safety. How safety is whatever the food you are consuming is safe or not. Is it safe or not? You have to ensure. How can you ensure? How can you ensure? See, each and everything. Suppose I can give you one example. I can give you one example. Like I have sown the seeds. Then this seed has been sown in so and so particular area in a particular soil. Okay, these particular things are sent to these particular IoT related things, and further it is sent to the blockchain. Okay, and after sometimes I'll use the pesticide and insecticide. Again, I'll use the I'll send the details. Okay, and suppose rainfall related, my sensor related information will be sending to the centralized system, or some heating related, or each and everything. Now my production has, now it has been produced. There is a very good production. Now I have to send it to either warehouse, or I have to send it to the food processing unit. Now, or what I will do is, I got the production, and I got very good production, and I'll just call the bidders, or I'll go to the market. To sell these particular items. Now, different people come and they will bid it, and accordingly, one particular person will take. That particular bidder will take the each and every information of your IoT or blockchain. Your centralized system data will be carried out by that particular bidder, because he has to ensure that in which climatic condition, in which particular water content, in which particular pesticide and insecticide this particular crop has been grown. Each and every information will be taken from you with the help of IoT and blockchain. Okay, he will carry out and he will process that particular food content. He will process in this in his food processing unit, and that particular food whatever he has processed, again suppose that particular food is processed in Delhi. It is processed in Delhi, and from Delhi it has to reach to the Hyderabad. From Delhi to Hyderabad, it may take some 5 days lorry transport. And suppose that particular food item, it is not a IoT controlled system. If it is not a IoT controlled system, then whatever the food items which has been transported from the Delhi to Hyderabad, it may spoil. Or suppose it has been spoiled. Then whose mistake it is? So once the food has been spoiled, then whose mistake that particular food related it is? Because here the food processing company has to take care. They have to take care while transferring from the source to destination. they should have heating related system, whether that particular transporting van or transporting lorry or transporting motor vehicle is having a related IoT related system or not. Suppose it needs some cooling system. It needs some cooling system. Suppose if you see some ice cream particular box, ice cream box, from source to destination you are carrying, then it has to carry within this particular so and so box only. You cannot carry open. If you carry in open, then it will be, it becomes a water. In the same way, whenever you are sending from the source to destination, whenever you are sending from the source to destination, then is these particular food items or food items has been maintained within this particular constraint temperature or not, within the needed parameter or not. We need to have those particular things. Okay, now the food particular items has been transferred from the Delhi to Hyderabad, and from Hyderabad to again it will go to local godowns, and from local godowns to the local kirana shops and supermarket and so on, and again ultimately the consumer. At the time of consumer may get the spoiled item. Now consumer may get the spoiled item. Again he will go to the kirana shop. Again kirana shop, no, this is not the thing. I got the very good item, but whenever you got it in your hand, it has been spoiled. It is not my mistake. Again, see, each and everything is available. There, what sort of QR code is available, scanning code is available. If you can scan that particular one, then you will get the entire history. You will get the entire history, where it has been sown, where it has been produced, and who is the owner, and who is the owner, on what conditions, on what climatic condition it has been grown, and who has bidded this particular food item, when it has been bidded, and when it has been processed, from where it has been processed, and from where it has been transferred to this particular Hyderabad, when it has been arrived in Hyderabad, and when it has been went to this particular thing. So that means each and every information is available with this particular blockchain. Everything is available. That means you cannot say that you are the victim. You cannot say that you are the victim. You pay for this. That means you can easily understand where it has been spoiled, why it has been spoiled. You can easily you can easily track the transparency. You can easily get related information. So using blockchain such as crop quality or seed or weather related, you can easily have data captured by IoT sensors manually by farmers, may be saved in distributed storage in blockchain sometimes. Okay, so like crops are grown up, food processing companies start bidding, they'll be start bidding it. Okay, and once they will bid it, again it will be transported via IoT enabled vehicles or not. Okay, you need to capture the temperatures of the particular related vehicle, related temperature, or in what sort of vehicle it has been transported, and so on. All this you can have it like. Okay, that means every stage, I am telling you, each and every stage, from starting to the end, to that particular item gets to the consumer. Each and every step it will be noted. It will be noted at each and every step. Transparency is checked at there is a transparency at each and every stage. Information gathered can help retailers to confirm if the delivered food is quality or not. You need to check it whether whatever the delivered food is quality or not. Okay, so when I'll get the this one, that means I'll check it. Suppose I'm having a mobile. Within the mobile, I'll just check it. I'll just scan it, and you will understand. You can understand before you will take that particular item. You can understand whether it is worth or what sort of pesticide content, what sort of insecticide content, or what sort of in which climatic condition, or like as we have discussed. Suppose that particular food has been, or that particular fruit is grown in Kashmir, but it is grown in Delhi or Mumbai, but they are telling that it is in Kashmir related apple. That means each and everything you can easily understand. You can get each and every information like. Okay, so storing data on blockchain, ensuring quality met at each and every stage. That means with the help of blockchain, we can say that quality has been met at each and every stage. You are not compromising with the quality. Okay, so with this, I want to stop here and over to Gautam sir.
Yes, sir. You gave the new insight in the application of the IoT with the machine learning and AI with the help of the blockchain. So there are some query on the chat box. So if you just see the chat box from the Sudhir Sharma,
You can ask, sir. You can ask it. Not a problem.
So rainfall prediction is uncertain. How it is not well distributed. We can't distribute the rainfall. There is one query from the Sudhir Sharma. So if you are giving the answer, so our participant will be very happy.
Yeah, rainfall, it is not known. We cannot predict the rainfall. We cannot predict the rainfall with the current systems. Conventional farmers are not getting huge profit because see, if they are known when it rainfalls, accordingly what we can have, we will not use the pesticide today or insecticide. If we can use pesticide or insecticide today, and if it rains today, then there is no use of using that particular pesticide. So that is the thing. We are getting the huge losses, and farmer is not aware. And sometimes see, if rainfall stations, what they will tell, sometimes there is a heavy rainfall today within Hyderabad region or within this particular Mumbai region, but on that particular day maybe there will not be, sometimes there may not be some rain. That means the system may not be that much accurate to tell that there is no accurate system that rainfall is going to have 100% accurate at this particular position or this particular current location on today and so on. Like.
So thank you, sir. There is another question from the Dr. He is the new in the blockchain category, but asking for the major software and coding language used for the blockchain. Hello, sir.
Yeah. I didn't get you, sir.
Major software and coding platform for the blockchain point of view. Am I audible, sir?
I'm not getting, sir.
So what kind of the software and the coding platform are used for the blockchain point of view?
Okay, blockchain related softwares.
Yeah, yes.
Blockchain related softwares, maybe like maybe you can use Python.
Okay, sir.
Yeah.
So there is another question: why the blockchain is not called the transparent chain?
The transparency is like whenever we can add a particular data in these particular blocks, we cannot alter it. It is not possible. See, like if you can see the registrations, land registrations, and so on, like suppose we have land registrations, there will be a link with a different documents, like who is the link. That means whenever I want to buy a particular land, based upon I'll just see the link, who's the land it is, and when he has purchased, and I'll be getting total history again from him, from where he has brought it, and like I'll be getting the total chain. With the current system, there is a possibility like we can alter the data, we can update. There are possibilities. I'm not telling there are possibilities we can alter, but with the help of this particular blockchain, it is not possible to alter or change or update with the particular with the help of this particular blockchain systems. It is not possible.
So this is the end of our last session, last session of the FDP. So on behalf of the GTU, British School of Engineering and Technology, and the Center for Continuing Education, NIT Warangal, I am very thankful to the Dr. Rajiv Bhukia for sharing the time for us and to give the new direction about the blockchain, how it can be useful in the IoT solution, in the machine learning and the AI. We are very thankful to you for providing the new kind of the insight about the blockchain in the IoT solution. Thank you, sir.
Thank
Now,
you, sir. Thank
we
you.
are going to, yes, sir, yes. Now we are going to start the valedictory function within the 5 minutes. Hello, Modi sir.
Hello, very good afternoon. Gautam ji.
Yes, sir. Namaskar, sir. Your voice is echoing, sir.
Is it so now?
Yes, still echoing.
So I am connected with mobile.
Okay, now it is now okay.
So it is echoing.
There is a echo, sir. Sir, there is a echo from your side, sir. So your mic is unmute, sir. Hello, sir.
It's okay now.
Sir, report. There was a report from your side, sir.
How do we solve this? I'm downloading this app from system. That would be better.
If you have the earphone, then you can.
It's fine now. It's fine now. The source is moving.
Echo. Just a minute.
Professor Ruchita. Please make your video on. Yes, sir. Yes, madam. Pancha side. Hello. I talk.
Hello.
Yes, sir.
How is it? Is it still echo is coming?
No, it is okay. No, sir. It is fine now.
Hello.
Yes, sir.
Hello.
Okay, you are audible, sir.
Okay. Thank you.
Shall we start the session?
Yes. Yes, Pancha said. Okay, Professor Rubika, madam, we can start our delivery.
Okay. A very hearty good afternoon to all the dignitaries and all the fellow participants present here. Here we have with us Mr. C.A.S. Associate Director, CCE Hyderabad, Dr. Raju Bukya, Assistant Professor at IIT Warangal, and Dr. S.D. Panchal, Director, GTU Graduate School of Engineering and Technology. I, Ritika Garia, Assistant Professor, GTU Graduate School of Engineering and Technology, would like to welcome you all on the valedictory session of the Faculty Development Program on Internet of Things with Machine Learning and Artificial Intelligence, organized by GTU GSET in association with CCE and NIT Warangal under IACA. So first, I would like to request Professor Gautam Makwana, Associate Professor, GTU GSET, to give the summary about FDP.
Thank you, Speaker Madam. Namaskar to everyone and good afternoon to all the dignitaries and all the participants. As being the coordinator of the FDP, behalf of the GTU, that is School of Engineering and Technology, and the Center for Continuing Education, NIT Warangal, we are organized a 5-day online faculty development program on the Internet of Things with the machine learning and artificial intelligence. This faculty development program is sponsored by the Information Security Education and Awareness, that is the ISEA Product 2, and in this case, the objective of this FDP is to give the basic idea, architecture, programming, and for the IoT, machine learning, and AI, artificial intelligence, and to give the news insight about this new technology and the new direction of the research as per the given in the National Education Policy 2020. And another point is we have invited faculty member as a resource person from the IIT Dhanbad, that is giving the new insight and their finding on the machine learning and AI. In this FDP, it is happy to inform you that there are more than 1,400 registrations across the India and outside the India. There are the 22 states of the India, from the Jammu Kashmir to the Kerala, and from the Gujarat to the West Bengal. We have received the registration from the various parts of the India, and also we have received the registration from the 12 countries: Philippines, Nepal, Kenya, Indonesia, Sri Lanka, Bangladesh, Muscat, Nigeria, Libya, and Cambodia. Also, we have received more than 100 registrations from the industrial technocrats. That is starting from the Indian Navy, Indian Air Force, CID, Prasar Bharati, CSIR, IBM, Oracle, SR Heavy, Engineer, ISEC, IBR, ISRO, Adani Power, CDEC, All India Radio, various crime investigation department, home department, cyber crime cell, forensic science laboratory, Punjab Police Academic, and there are many more IT related industry and startup across the India. We have received more than 500 participation from the outside the Gujarat, and involved the 60 university and the 550 engineering college in this FDP. And because of the limitation of the online platform and the smooth conduction of the FDP, we have selected only 200 participation in our FDP that contain the 46 industry person, 9 professor, 9 associate professor, 98 assistant professor, 11 PhD student in this area, and the 20 PG students are working in this area. Now, during the FDP, we have invited Professor M. C. Kumar from the Santa Clara University, California, USA. We conducted the 3 sessions during this FDP that contained the overview of the IoT, demonstration of the various case studies based on the IoT, and how the machine learning and AI can be incorporated in the IoT devices. And he took the session from the California and demonstrated the various kind of the solution based on the social distancing detection demonstration, home security, driver drowsiness system, and the monitor system of the flood and the traffic monitoring system. With the help of their own finding on platform based on the IoT and the machine learning. So this is by the Professor M. Kumar. Also, we have the Dr. A. Chandrasekhar Rao from the IIT Dhanbad. His topic was the AI in bioinformatics. We include the basic algorithm, which is a PSO, reinforcement learning, genetic algorithm, and the application and genesis of AI in bioinformatics. Also, we have the Professor B. Ramesh, Assistant Professor at the IIT Dhanbad, and his topic was how the machine learning in the agriculture. Machine learning in the agriculture. He demonstrated the various his finding about the how to improve the productivity of the various crops based on the land available and available in the Karnataka state. Also, he have find out demonstrated his finding about the irrigation system and the smart agricultural model based on the jail research project at the IIT Dhanbad. He gave the new insight about the application of the IoT with the machine learning and AI in the agriculture for the use of the our farmer for the our future solution about the food security. Also, we have there is some noise from the someone. So also we have the Professor E. Suresh Babu, Assistant Professor from the NIT Warangal. So his topic was the role of the ML machine learning in IoT. Give the insight about the fog computing, edge computing, basic architecture, network model, protocol model, IWF reference model with the IoT, and give the insight about the various IoT, various cyber attack in the IoT and how the security of the IoT can be handled. Also, he gave the about the how the machine learning can be implemented in the IoT solution. Also, we have the Professor Raju Bhutia, Assistant Professor in the NIT Warangal at the Department of the Computer Science and Engineering, and his topic was the blockchain in the agriculture. He gave the new insight about how the blockchain can be used in the IoT solution for various kind of the issues regarding the agriculture point of view, for the farmer point of view, and from the crop point of view. And also we have the two persons from the industry, Mr. A. Bharat from the X-Class Solution from the Bangalore. He gave the about the various hardware and the software platform used in the IoT and the IoT in machine learning, and the demonstrated the various solutions such as the object detection, mass detection, face detection used in the healthcare industry, and also give the insight about the various kind of the Python programming, the cell programming with the participation also. Also, we have the Mr. Prasad from the Knowledge for You Infotech. It is the K4U Infotech regarding the how various kind of the software required for the IoT, machine learning, and AI. How it can be installation, how can be detected the error into the various kind of the programming tool. It is the Python, Jupyter, Anaconda, TensorFlow, CUDA, and also the various Python packages like the Pandas, NumPy, MATLAB, Plotly. And also he gave the his project, that is the detection of the COVID-19 by the use of the X-rays, and he gave the how the machine learning And the AI can be useful for the COVID-19 detection. And he successfully saw the demonstration about the COVID-19 patient based on the RT-PCR and the AI. Also, he gave the demonstration about the how the device at the Bangalore can be controlled by the from the Ahmedabad by the Chinmay Vyas. He gave the demonstration about the use of the IOT application that at the remote area, at any part of the India, any person can control any device with the use of the Internet of Things. He gave the very good demonstration about our participation. Mr. Chinmay, sitting at Ahmedabad, can control the device at the Bangalore. So this is a very good demonstration by the Mr. M. Prasad, and I am very thankful to all the resource person of this FDP. Without this resource person, the objective of the FDP is not fulfilled. And I am sure all the participation get more insight about the new kind of the direction into the research point of view in the IoT, machine learning, and the AI. And we are very happy to help them to make the new kind of the collaboration work with the you, with the us, and from the IoT, from the our research person. I think without the participation, I am very thankful to all the participation. There are the many kind of the issue regarding the network connectivity from the our side and from the your side. And this is a COVID-19 situation. We have to continue our mission about the knowledge sharing and the new kind of the involvement in the new knowledge, creation of the new knowledge with the help of the resource person, and we have to contribute something from our nation. This is and we will take care about all the issues regarding the attendance point of view, and we will give the all the certificates very soon. So this is from my side. Over to Professor Rudika.
Thank you so much, sir, for the detailed information. Now, I would like to request the participants to share their experience about the program. One by one, you can unmute your mic and share the feedback. I request all other participants to keep their mic off.
Hello.
Yes, sir.
Am I audible to all of you?
Yes, sir. Yes, sir. Kindly introduce yourself and then you give your feedback, sir.
Sure. I am Dr. Chandresh Parekh, Assistant Professor Telecommunication from Raksha Shakti University. It's my pleasure to give feedback on a very wonderful FDP on IoT with machine learning and deep learning. Really, in such a very critical situation across the India and world, in the pandemic situation, it is very difficult to engage participants actively and interactively on such FDP. But it happens in this particular FDP. I congratulate GSET, Gujarat Technological University Coordinator and Authority, as well as NIT Warangal Coordinator Professor Raika, Coordinator GTU Professor Makwana sir, and his team. I also extend my sincere gratitude all the speakers who have actually delivered these contents very nicely and in a very understandable manner. Otherwise, this particular success could not happen. So, my heartiest gratitude to all the speakers. I also thanks to all participants who have actually played their role by interacting with the speakers and like beginners like me could understand without such interactivity. Really, it was
There is some echo.
Hello. Hello.
Yeah, continue, sir. Hello, continue, sir.
Okay. I think I was at the point to thank you all the participants also who have played their role best by interacting with the experts, and same expectation we keep from GTU, the first and best university in a technological field in Gujarat. So thank you all, and thank you all course coordinator, experts, and faculty members. Thank you.
Thank you so much, sir. Anybody else?
Myself, Dr. C.H. Vitlani from Government Engineering College, Rajkot. I want to share my feedback with this.
Yes, sir.
So this faculty development program on Internet of Things with machine learning and artificial intelligence was organized by GTU, Graduate School of Engineering and Technology. Machine learning is basically a subset of artificial intelligence, and this field is very broad. And if we want to cover this, I think it will take a 1 year period. And you also combine the Internet of Things, which itself will require 6 months if you want to, develop a skills for hands-on in programming. But, I congratulate coordinators, Dr. Gautam Bakwana sir, Dr. Raju, Professor Sutar, and his team for successfully organizing a faculty development program in such a emerging area. It was a very good combination of experts from industries and academia, and you also accommodated some training partners along with that. I want to give the feedback on few sessions, like it was arranged by Siva Kumar from University of Santa Clara, California, USA. He started from basics of IOT and discussed the application of machine learning to fight with the COVID-19 situation. He has given illustration for different applications like monitoring of traffic at public places, monitoring of activities in isolation wards, monitoring air quality, body temperature measurement using thermal camera, social distance monitoring, automatic mask detection and warning system, driver drowsiness system. From that, I also got some idea that during the online sessions we should also do some work on participant drowsiness system, because it happens if there are continuous lectures are going on. The liver flooding detection, alert system, etc. Then few I want also very much thankful to Dr. Ramesh. I discussed machine learning application for the agriculture purpose, and described very nicely the integration of machine learning algorithm with IoT. The sensors are producing a lot of IoT data and sending to cloud. So machine learning will analyze the data at cloud and provide the useful outcome. The sessions by Benath Prasad was, given a practical aspects of all Python programming, starting from the installation to the application. Dr. Babu described the role of machine learning in Internet of Things. Professor Raju today, tried to illustrate the use of blockchain for the agriculture purpose. And I have seen that during the sessions, there was a prompt response of participants. Whenever, there was a questions from the expert, all the participants were very much active in a chat section. And participants are also very much active in a WhatsApp group. Many participants face the problem like no audio, freezing of a screen during the sessions, but it is a part of our online life. Because now we are used to all the such problems. Most frequently asked questions nowadays from the participants and lectures professors are that whether I am audible, am I audible, is my screen is visible. These are frequently asked questions during the online sessions. It was our pleasure to interact with all the experts through chat session. Thank you very much, GTU and our team, for giving such wonderful opportunity to us for attending the sessions. Thank you very much.
Thank you so much, sir, for your kind words. Now, anybody else?
Hello, good afternoon.
Good afternoon, sir.
My name is Yusuf Haider, and I am a faculty working in Muscat. And I can openly say this is one of the best workshops that I have ever attended, mainly for three reasons. One is that most of the speakers spoke from their practical experience, their own experience, and it was very connecting to us. Point number two, because all the speakers, most of the speakers, they spoke about the real-time applications, the practical applications that machine learning or IoT is incorporated, where it is incorporated, where it is implemented, and so on. So that was also very connecting. Point number three, why this is one of the best workshops that I've attended is because of the organizers. You know, despite being it online and all these connection issues that we have, internet connection, and all other issues related to, as the second speaker just talked about. Am I audible? Is the screen visible? So there are so many issues. Despite all these issues, the organizers were already there and always there to sort out the issues, sort out the problems that we faced. And all the speakers, very enthusiastic to pose the questions and get the feedback from the participants. And despite all these issues related to internet, related to the topics that was being discussed, because some of the topics that they're part of this FDP, it was new to me, but along with Google search with another device, and I was able to follow all these topics. That is another reason why I thought this FDP was one of the best that I have attended. And thank you all the speakers, all the organizers for conducting such a beautiful workshop, and expecting many such workshops in the future to attend. Thank you very much.
Thank you so much.
Hello, I am Vishwajit Thakur.
Yes, sir.
Hello, I am audible?
Yes, sir.
Yeah, I am Vishwajit,
Yes, sir,
Vishwajit Thakur from Anand. I am Vishwajit Thakur from Anand, and I want to give a feedback about this 5 days program. Looking at the title, it was a very timely organization of this workshop, because many people know about IoT, many people know about AI, many people know about machine learning, but altogether how to put it up in an IoT framework. To put AI and machine learning in an IoT framework was one of the most important requirement of today's learner. So I have learned for this 5 days very much. The 3 days on IoT experimentation, IoT applications were very well explained. Today, in fact, that IoT World Forum on Reference Model, which was presented by Dr. Babu, was also very novel as compared to a standard OSI reference framework. I also congratulate all the organizers for excellent time management. In spite of this is being a remote, everybody was coming right on time, and the program was getting finished also on writing time. I have seen that most of the participants were consistent for all the day, and the participation has reached up to 124 along with all organizers. That is what it is doing. So I'm really thankful for the GTU for organizing such a nice, wonderful FDP for the faculty members and all the supporting and sponsoring body. Thank you very much.
Good afternoon. Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, I am Ritesh Sukandi. I belong to Institute of Plasma Research, HBNI, and I have attended this program. I would like to congratulate GTU and organizer for this good event. This technology changes very rapid, and I think government policies are accordingly adjusting itself. So this technology has a lot of scope in future. But I would like to emphasize on the point that it's mathematics and statistics, as well as embedded systems, these are the backbone of these two technologies, IoT and machine learning. So I think this also needs a lot of work in the fundamental areas. This will reflected back into the development of IoT and machine learning. That's all from my side. Thank you very much.
Thank you so much, sir. Now, anybody else want to say something on this program? Yes.
Hello. Am I audible, ma'am?
Yes, sir.
Yes.
Good afternoon, everyone. This is Anurag Singh Yadav, Assistant Professor, Environment College of Engineering and Technology, Bareilly. All the sessions are very informative. I have learned a lot key concept in machine learning, IoT, AI, and its application. This is really a very wonderful session for me, and thank you so much, organizers and their team for the wonderful provided an opportunity for me. Thank you, GTU and NIT Warangal for the organize such a wonderful FDP. Thank you, ma'am. Thank you, everyone.
Thank you so much, sir. Thank you. Anyone? Okay, so now moving ahead, here we have with us Dr. Raju Bukya sir. Sir is currently working as an assistant professor in Department of Computer Science and Engineering at NIT Warangal. His research areas are software engineering, bioinformatics, IoT, and machine learning. He has published more than 30 research papers. He has also received a Best Session Chair Award for the conference in Karnataka. So, sir, I would like to invite you for to address the audience. Bukya, sir.
Director ISCA Satyanarayana Murthy Garu, Director GTU Graduate School of Engineering and Technology Professor Silas Panchal Garu, Coordinators Dr. Gautam, Dr. Margam Sutar, participants, good afternoon everyone. First of all, I would like to thank our Director NIT Warangal for giving the opportunity to conduct 5 days FDP program, and I would also thank Director GTU and Gautam sir for giving us the opportunity to conduct in your institute. Okay, within a very short time, we have reached nearly 1400 to 1500, and every day we used to discuss what was the number and so on. Within just 3 to 4 days, it went to 1500 participants, a very good number, and it is going higher and higher, but we have to select a maximum of 200 to 180 to 200, then we stopped there. And many people, many participants are used to call us, why you are not able to accommodate us. We have applied, and we are very much interested to join this FDP, but due to different constraints, we are not able to accommodate those people. We are very sorry for that. Coming to today's, we came to an end of 5 days FDP program under CCE, Internet of Things and Machine Learning and AI. In combination with the Department of CSE and ECE, GTU Graduate School of Engineering and Technology with 180 participants. All the sessions went absolutely good, and we got very good feedback, which was very good. We had covered various topics in machine learning, Internet of Things, and blockchain technology. I think the participant has enjoyed well with this particular FDP program. Coming to the Center for Continuing Education, till now Center for Continuing Education has conducted 16 FDPs within a short span of time of 3 months. And we have trained 1334 faculties. By the end of September, we are going to complete 18 programs, and by the end of this particular December, we are going to complete 30 FDP programs. Faculty, students, research scholars, professionals, employees can participate and utilize the workshops, seminars, FDP programs. CCE is providing the learning opportunities to the professionals, and we can have the MOUs with engineering colleges and so on. CCE-NITW is providing the online as well as the offline FDPs within and outside the institute from time to time. And now we are conducting only online FDP programs. CCE-NITW is interested to conduct FDP programs in collaboration with various engineering colleges throughout India, like engineering colleges, MCA colleges, MBA, professional institution for updating knowledge for their faculty. I request all the faculty to utilize this wonderful opportunity with a nominal registration fees of 500 for 5 days and 1000 rupees for 10 days. So with these few words, I thank each and everyone for giving me this opportunity. Thank you everyone.
Thank you so much, sir, for your address. Now, here we have with us our today's chief guest, Sri A.S. Murthy, sir. Sir is currently working as an associate director at CDEC Hyderabad. As a part of systems, networks, and cybersecurity teams with technology leadership, he has more than 20 years of experience. He is passionate about technology and IT management in business transformation. His research management, vision, and contribution also encompasses into many fields, having initiated Param Computing Facility at CDEC Hyderabad. Sir, I request you to address the audience.
Thank you very much. First of all, I for inviting me for this particular validator function, that 5-day online faculty development program on Internet of Things with machine learning and artificial intelligence. So GSET, for that I have to thank you, and also of course Vice Chancellor Naveen Shetji. Basically, the encouraging to conduct such kind of programs were very important at this moment because of the emerging technologies which are coming in such a way that the cyber security and other emerging technologies like blockchain technologies, 3D printing, etc., etc. So I always be appreciate as part of IACA program and associating with the various institutes where the technology is important, and other IC participating institutes like IIT, ISM Dhanbad, NIT Warangal, because these both institutes are part of IACA program. Incidentally, of course, the departments may be a separate departments, but however, it's like that collaboration with among 3 or 4 institutes with respect to technology is very important to make awareing of various coming technologies, upcoming technologies, and emerging technologies. So with the respected Gautam, Professor Gautam, and SD Panchal, director, and also another coordinator, Dr. Raju Bhya from NIT. So with and also the participants, is a very good afternoon. So because for any program, the feedback is very much important. See, which I have gone through some of the feedback from Dr. Chandresh Parekh, Raksha University, Dr. C.H. Vitalash, and even the Muhammad Yusuf from Muscat. So, and also somebody from Anurag Singh, I think, Madhur Bareilly, UP. So all these people, the people are across India and even the global. So attended this program. That is one is the very good thing, very good insight for conducting as many programs for GTU and even though as part of ISC also. So the feedback is very excellent. And also the majorly the people are saying about various problems, like let's say take example of that is what that required the problems. When the problems are not there, we cannot do anything, we cannot understand the people. So during this pandemic, so and majorly most of the people are going through online. If somebody is saying that I'm not able to see your picture or I am not able to listen about your audio, if these things are not there, then there is no interest. So we should have such kind of interaction, so that how much interest the people are having with respect to this particular technologies what we are going through. So that's what is giving a kind of very, I understood that the people are having a lot of discussions, questionnaire, and interactions. That is what the feedback was very excellent. and it gives like an immense pleasure to each and everybody, GTU, ISEA, to conduct as many as programs as things. So coming to that, I think so nowadays AI is artificial intelligence. Some even though somebody said maybe the name I forgot, but however, or maybe it's the Biswajit or Dr. Ritesh said that artificial intelligence, and I think Dr. C.H. Vitalaks, maybe his ML is part of artificial intelligence, of course. So whatever the super and sub technologies, so now artificial intelligence everybody wants. Everybody knows they need to invest something either in pilot project or an initial project. They wanted to conclude or they wanted to bring these technologies into their projects. So artificially, because of whatever that the growth of the internet technologies, so AI is like now it is majorly coming towards the application sides because of the technology growth. But the artificial intelligence and machine learning technology is not is a new technology at all. Yes, maybe that some of the universities, some of the IITs, like you take example of we have in a Central University, Hyderabad Central University, the AI lab in 90s. So major IITs are started this kind of labs in the long back, but because of the technology growth and other people are working towards these towards the applications mainly. So let's say example of some I think NIT Warangal has taken some lectures towards agriculture side. So it is moving towards every application, these emerging technologies, and it also goes further as many as applications. Every human being need an artificial intelligence at this moment. So we all need to work towards that. So, but along with that, if you see that every application or every system has its own gap areas, vulnerabilities. So that security is must every applications. So we need to rightly appreciate every developer, every application, every researcher to work towards these technologies. But along with that, it is very important to make understand about the cybersecurity, information security while they design initially, while design time and developing time, so that we can reduce as many as security gaps while we are delivering towards the applications. So this is one important thing we need to understand. Otherwise, AML can provide insights from the data to the further enhanced to intelligence, and the capabilities of it's not only limited to IoT applications. Any kind of applications you take it, so it's giving as much as insight and intelligence, so that this technology is must, and it is rightly right time GTU conducted. In the other side, last month IIT Guwahati as part of ISA program, they also conducted. So because there's one institute or together 3 or 4 institutes is not possible to conduct and complete this one. So that that's what we are encouraging to conduct all these technological things. Either IIT Guwahati is conducted on majorly on social media analytics, AML and all. So every application, every division we required, and along with that, like it's now we conducted IoT. Maybe we need to also have to look about the other emerging technology like blockchain technologies specifically, and darknet technologies, and 3D technology, 3D printing, and generally that applications like in agriculture. So we need to conduct such programs continuously, and we are encouraging all institutes of ISE institutes, information security education and awareness. This program is bought by Ministry of Electronics and Information Technology as a project, but it is not a new program. Where we started this program during the period of 2004-5 initially, where the CERT as part of the national importance CERT as Computer Emergency Response Team was established during the part of IT Act 2000. In those days, this was started. Because of this is the capacity and capability building with respect mainly at educational level. So it is started in delay, and at the first phase, which we associated with 32 institutes, where in second phase is 54 institutes. See, basically these institutes are acting as a three groups. One first group is the Information Security Research Development Centers. IIT Madras with respect to hardware security, IISc Bangalore with respect to cryptography, and IIT Guwahati is mainly on IoT and social media analytics. And IIT Mumbai is mathematical expressions and required for the cyber security and blockchain technologies. So these four centers are working as an information security research and development centers as part of ISEA. And there are 7 resource centers, IIT Roorkee, IIT Kharagpur, and NITs, NIT Surathkal, NIT Surat, NIT Warangal, and NIT Roorkee. There are total 7 institutes are working as a resource centers to support the various participating institutes to take information security education program with all other NITs and IITs which they are participating in this program. So along with all these institutes, there are 5 institutes. These are very good institutes which we are always happy for their performance. These institutes are technical universities. So one of the technical universities is GTU, Gujarat Technological University, along with JNTU Hyderabad, West Bengal Technical University, and Rajiv Gandhi Technical University in Bhopal. These are the 5 institutes which they are working continuously transfer this thing like from premier institutes to all engineering colleges, because the technical university which we consider basically is that the technological university is the major bridge between all engineering colleges and the premier institutes. So that's what GT is playing a very important role, and we are very happy that other 2 institutes like ISM Dhanbad is also part of our ISA program, and NIT Warangal, and collaboratively conducted this training program, and gives a lot of impressions. And it's not stopping here, and we will try to implement various technologies like AI for edge computing, and we are also thinking about third phase which we need to look about the towards that advanced emerging technologies like a 5G context, AI-based recommendation systems, distributed machine learning, interpretable machine learning. Other than these IoT applications, the remaining whatever the emerging technologies we wanted to bring it and conduct such kind of and initiate such kind of initiatives. So this program is as part of education. Other training programs are government official training and public awareness, general awareness in cyber security, where again G2 is implementing in a major role to conduct a general awareness for public. So that is very important. Cyber hygiene is very important with both personal and even the national interest. As you people all know that there are a lot of data breaches are happening. Everybody is pointing out only one country because of their present situation, but it can happen from any country. So we are all part of fifth space. So in 1970s, generally the finals other than land, air, water. So only the space is the one next to for the world wars. But now that is wrong to prove that there is already space, that is cyberspaces came. So whatever the technologies we are implementing, IoT or 3D printing, blockchain technologies, IT, anything. Now we are moving from traditional to cyber mode, so that we should be very careful. And we are already in the fifth space with respect to the war. When it is coming to the in case in tomorrow any 2 countries in conflict, some kind of conflict. So this is the fifth space war. So that's what we should be very more cyber vigilant individually, because losing 10 rupees from your account and transferring to other country is itself is the losing the some kind of an so if you are making a total, there is expected that there are 2,000 crore rupees last 3 years were transferred from our country to another countries like I won't mention which countries at this moment, but you look into that 2,000 crore of foreign fund we lost. So as it is a national that all automatically becomes a national interest. So we need to secure ourselves, and we have to go and secure our society also. So that is where we should be responsible. So with this, I congratulate once again entire GSET team, GTU, for conducting such beautiful and technological trainings and transferring the technology from to the engineering college and other institutes to become and make our nation as a strong with respect to the technology's growth. I thank each and everybody who are participated and given a nice feedback. And of course, it is a less smaller time and everybody can't give it. Hope you have given entire feedback, because your feedback gives to us or anybody to take care of that next batches and transfer the technologies as per that your feedback. Thank you very much once again, and thank you Professor S.D. Panchal for inviting me, and coordinators, especially Gautamji and Raju, Professor Raju. Thank you very much.
Thank you so much, sir, for the valuable information, the encouragement, and the address. Now, I would like to invite Dr. Professor S.D. Panchal, Director GSET, to share his concluding remarks on the FDP.
Good afternoon, everybody. Am I audible?
Yes, sir.
So, first of all, Honorable Associate Director ISEA and Chief Guest of the today's valedictory session, Mr. C.S. Murthy sir, Coordinator of the event, Dr. Makwana, Dr. Raju from NIT Warangal, and dear participants. First of all, I would like to congratulate all of you for getting a wonderful opportunity to attend the very valuable faculty development program on the theme of Internet of Things and Machine Learning and Artificial Intelligence. As Dr. Makwana already mentioned in the beginning, total 1400 participant or registrations we got, and out of that, only 180 participants we have shortlisted. And it shows that the participants, those who have selected, they are lucky enough. Inaugural session is a very important, valedictory session is basically a very important to get the feedbacks from the participant. And based on that one, definitely the next program, we can incorporate all the suggestions that we have received during the current program. First of all, I would like to also thanks the ISEA project. Thanks to Murthy sir for providing us this opportunity to conduct such a kind of awareness program specifically in the security domain in education sector. And due to that only, we are in a position to conduct such a wonderful faculty development program. Till December, we have total 8 FDPs planned under the ISEA in the various emerging areas. Sir, it is a very proud moment for all of us. We are also planning to visit each and every village surrounding the GTU, and also we have planned to interact with the school children, specifically to create the awareness in the security domain. As Murthy sir is rightly said that our basic objective of the ISEA is to just create awareness specifically in the security domain. But the FTP would be a target only to the technological person or technical person, where they can enhance their understanding. But the important area that we should have to focus is the villages and school children. Basically, much awareness is required in this particular sector. Nowadays, even a village also, many peoples are using the financial wallets. Many peoples are nowadays using the various social media platforms. even school children also during the pandemic situation, everything is now online. So many school children are also now well aware about the various social medias as well as the online platforms. But at the same time, it is our responsibility to provide them a right guidance so that the security will be ensured and they will be not affected by anyone else. So this is the basically main sector, school and villages, where GTU want to focus in coming days. During the session, very wonderful feedbacks we have received, specifically from the Chandresh Parekh, Professor C.H. Vithlani, Professor Haidar, Professor Viswajit Thakur, Professor Ritesh, and Professor Anurag. They have given a wonderful feedbacks and they have also given a very good suggestion. So definitely, I will ensure them to incorporate all those suggestions in coming FDPs. I request all the participants also keep frequently visiting the GTU GSET websites because lot of workshop, lot of FDP in a row we are planning, and in a many FDP we have also launched the calendar. So in a very short time we will put it into on our website, and I request all of you to take advantage of it. Now I also request the coordinator to think for the second phase of this FDP for those participants anyhow they could not able to participate in this particular first phase. So that is the request from my side also to coordinate to look into the opportunity and the possibility of the second phase of the same FDP, so that we can accommodate more 200 participants, those who are not selected during the first phase. Lastly, I congratulate both the coordinator for wonderful planning and wonderful arrangement during the these 5 days various online session. During the feedback, I was listening that many times there was a feedback like I'm not audible, voice is not proper, volume is not proper, noise is coming. This is the limitation of online platform. But day by day, it is becoming a matured and definitely it will be improved. But at the same time, I would like to draw attention. One of the biggest advantage of this online platform is we can able to bring a very good experts on these particular platforms. That might be not possible whenever we are conducting such kind of things physically. So this is the one of the biggest advantage of the online platforms. Even though from any corner of the world we can bring the experts. So that is a crucial advantage of the online platforms. So this my concluding remarks. I would like to thanks everybody, every participants, and I hope that the knowledge that you have pursued during these 5 days will be very fruitful in your domain. Thank you, sir. Thank you very much.
Thank you so much, sir, for giving the information about what GSET is doing and planning to do in the security field and your remarks. Now, I further request Professor Gautam Makwana, Associate Professor, GTU GSET, to give vote of thanks.
Am I audible?
Yes,
this
sir.
is a common question for the speaker. On behalf of the GTU, the School of Engineering and Technology, and the Center for Continuing Education, NIT Warangal, the coordinator of the FDP, it is my pleasure to offer the vote of same. I am very thankful to the Mr. Chandrapati Apara Satyanarayan Murthy, Associate Director and the Head of Department, Information Security Services, for being a head guest of chief guest of this function and giving the information regarding the activities and the focus of the ISEA department of the CDE. Thank you very much, sir, for spending your time. I am also thankful to the Professor N.V. Ramana Rao, the director of NIT Warangal, for providing this kind of the FDP and this lecture on the to make the effective online teaching during this COVID-19. I am very thankful to the director sir of the NIT Warangal. And I am also thankful to the Information Security Education and Awareness, that is the ISEA, to be the part of this FDP. He sponsored all the expenses whereby for the participation, year of the participation across the Gujarat and across the India and outside the India. I am very thankful to the ISEA Project 2 for sponsoring this wonderful FDP, and without the success of this FDP was not possible. Thank you again, ISEA. I am also thankful to the Center of Continuing Education, NIT Warangal, for giving the permission to organize the FDP and by our GTU GSET. And a special thank you to the faculty in charge of the CCE NIT Warangal, Professor Raju Bhukia, with him, we are able to find out the wonderful resource person as for the need of the FDP, as for the objective of it. Because without proper resource person, with the proper application, proper solution, with the integration of the same technology, IOT, machine learning, and artificial intelligence, the success is not possible. I am special thankful to Professor Raju Bhukia for coordinating this wonderful activity. I am also thankful to all the resource person. Without them, our objective and our learning attitude will not be fulfilled. So I am thankful to the Professor M. Kumar, Santa Clara University, California, Professor A. Chandrasekhar Rao, IIT Dhanbad, Professor B. Ramesh, IIT Dhanbad, Professor P. Suresh Babu, NIT Warangal, Professor Raju Bhukia, NIT Warangal, Mr. A. Gorat, X-Class Solution Bangalore, Mr. Prasad, K4U Solution from the Hyderabad. And without them, this is not success of the activity is not possible. And I am very thankful to Professor Mr. Prasad for coordinating the wonderful activity. This is the indirect help from the I received from the Mr. Prasad to make the all kind of the arrangement in the back of this FDP. I am very thankful to the Mr. Prasad for giving the moral support to conduct this FDP. And the last, for the participation across the Gujarat, across the India and outside the India. It is without you and without your active participation, the objective of our FDP and the outcome of the FDP cannot be fulfilled. So I am very thankful to one and all the participants. You are my hero, and without your participation, the FDP is not possible. At the last, I am also thankful to our Honorable Vice Chancellor Sir and the Registrar Sir, Dr. K.N. Kher, and the Professor Naveen Chet from their support and motivation from the first day of this FDP. When I have the idea of the organizing this FDP, our Vice Chancellor Sir giving the direct permission without delaying to organize this FDP. I am very thankful to all the higher authority of my university, that is Gujarat Technological University, and Professor Serasli Pancha, the director of the GTU, the School of Engineering and Technology. Under his guidance, under his instruction, the success of the FDP is possible. Without his support, this FDP would not be possible. I am heartily thankful to the Dr. Seriously Tunka sir for giving the opportunity to coordinate this FDP. Professor Margam Tushar, my member of my team member of this FDP, to make the all kind of the support. And the last, Professor Rutika for organizing, for anchoring of the my concern with this FDP, and all the staff members of the GTU and GSET. Without their support, this is not possible. I am also thankful to all my staff members of the GTU GSET. So that is from my end. Jai Hind to all, and all the feedback I will share within the 1 or 2 minutes on the WhatsApp group, and there is one quiz for the half an hour, and you have to finish the your quiz, and based on this you will get the all the requirement of the certification. So this is from my end. Thank you all.
Okay, thank you so much, sir. Now we are ending our FDP on Internet of Things with machine learning and artificial intelligence with a great ideas in our mind. So I express my sincere thanks to all the dignitaries and participants for your patience hearing. Now you can leave the online platform. Thank you so much.
Hello, is the validatory is over, sir?
Yes, validatory function is over, sir. Yes, sir.
Can you share a feedback link and a quiz, sir? It's a very humble request.
You can send. I have prepared the feedback link. I have. Yes. Exam. The link is given by the Prasad to me. So I am within the 1 or 2 minutes. I am sending. Okay. I will call you later on in the evening. Okay, everyone. This is the end of our FDP. This is the end of our FDP. Everyone, I am sending the link on the WhatsApp group. Thank you very much, sir. Yes, sir. Or feedback and both are there. Okay. Then okay. Okay. Thank you very much. So we will meet after. I will call you after half an hour. I will do now from the 8 o'clock time here. So we will. I will talk to you later, sir. Okay. Wow.